no available thread. And now the context changes. The context is the first available thread picks up the call. Like there was no available thread. So the first one that becomes available picks up the call, and it needs to know where it's coming from, and then pretty much simulate the adding that remote task as a waiter, right, remotely to that RT mutex. And this is kind of sketchy. Yeah, I guess. Yeah. I couldn't find though, like, is this I don't know whether or not this is like a legit use case for this API, and that's one of my problems here. I don't see any other there's one user outside of Utexes here that it's RCU, like this RCU boost K thread thing, but I don't know if this is like a correct approach or not.
So what you get by the interface is you get the lock, and how do you unlock it later?
Oh, sorry, I skipped that part. This was just the part of how you express the blocked on thing. But yeah, you definitely either block later, or you can clean up the lock that failed. When you do start proxy locked, it's already locked, so you failed to acquire it, then you can either lock later or clean it up. But yeah, I skipped that part for sure.
Okay.
Yeah.
Because the way the API works is that the kernel does all the PI thingy, and then once it gets back, you have the lock.
Yes.
Unlock it at some point. And Futex is the one user, RCU is the other user. Basically the same thing. Where, but this is the sneaky part. On RCU, you get assigned the lock to a different task, and then you do this proxy thingy on its behalf, and then you get away and let it handle it. And the task in RCU does notices, unlocks it, and it was never involved in the first place.
Yes, it's similar. The difference here is that the remote K thread needs to be woken up. And the problem with that is that there's like this chicken egg problem that you cannot block yourself and then wake up the remote thread. Yes. I mean, the thing is that it's the remote thread. It's sort of waiting on a completion, right? Like it's sleeping on that wake queue, and it needs to be woken up and say, "Hey, you have a call to process." That's a wake up interruptible call, and that needs to go after the priority has been inherited, and you cannot.
Isn't that what the PI convars do?
Sorry, was that again? Can you hear?
So the P thread convars, we have priority inheritance for those. There is a wrapper. What did I call it?
I don't think I'm familiar with this. I don't think I've ever heard.
So the PI convars do exactly what you're describing.
Oh,
they allow you to create a priority inheritance aware mutex. You associate that with a condition variable. The worker thread that you're talking about is there. The other one says,
Okay.
there's a wait and a signal, and then it does a in-kernel vicarious locking mechanism, which gets around the problem that I think you're describing right now. POSIX is a little tricky with that because it gets in the way of pure RT semantics, and so we have a wrapper called librtpi. We created that, I don't know, 10 years ago. Yeah, that was kind of. We did. Okay. Okay.
Okay. What do you say the name was?
librtpi.
Okay, librtpi. Okay, cool.
Yeah. Yeah. It uses reqpi. Mutex reqpi is the kernel mechanism, but librtpy makes use of that
of
mechanism.
that API. Okay.
That might address what you're trying to do.
Okay, thanks. And just to wrap things up, ideally, okay. We know proxy execution, it's the end goal. It just has the same fitting problem of expressing the blocked-on relationship, but yeah, that's it. Thank you very much.
Oh, not this one. Okay, so my session, it's about enabling push callback mechanism in the FAIR class. So having in mind that that's something I have worked on for a number of months, and I've put that a bit on hold, and I'm coming back on this. The goal of this is really to discuss about enabling push callback mechanism in the FAIR. That's something we already have in the deadline and the RT scheduling class. And also to make sure what would be interesting in the push callback for the FAIR class. I mean, what should be done, what we don't want to do. In my case, I'm mainly interested by this for the EES, the Energy Aware Scheduler. And one of the reasons is that we want to evaluate the task placements more often than just at wake up. Right now, we are doing that when the task wake up. And if the task wake up and sleep, I would say every few milliseconds, we are pretty okay to have the task placed correctly based on the Energy Aware Scheduler. But if at some point the tasks start to be runnable dozen or even 100 of milliseconds on the same CPU, then the first decision of selecting the CPU might not be relevant anymore. So we want to call more often the select CPU for a task, even if the task is still runnable and waiting to run on a CPU. That's one of our main reasons. And one can say why you're not waiting for the periodic load balance to do that. The first thing is that we are disabling the periodic load balance for the EES scheduler, because the periodic load balance first is really big, because the goal is to look at all the CPU to evaluate the load of all CPU at the scheduling level, and then selecting a CPU, and from that we will select, I would say, a random task among all the list. And in our case, we don't want to select a random task. So we would have to go through each and every task to select which one is the best, which is not really scalable. I mean, it can take a lot of time. And we already know that the periodic load balance take a lot of time. And that's why sometimes we're skipping the load balance when a CPU is newly idle, or when the CPU is idle, or even if it's busy. So the periodic load balance as it is right now doesn't scale at all when we are looking for each task placement. I would say it scales well at the CPU level, but not if we add the task level, then we'll not be able to sustain this kind of a way of working. So, and then the other part is that the periodic load balance happen every 32 times the weight of your scheduling group. So you can wait for dozens of milliseconds still, or even hundreds of milliseconds in some cases. So it's far too slow for us to re-evaluate that. So that's the main reason why we would like a push mechanism for EES. The other things is that we want to use the same policy everywhere. I mean, when we wake up, we are selecting a CPU using the EES, the find energy efficient CPU mechanism. And we would like to use always the same algorithm, just to make sure that from the wake up or to the periodic push mechanism, we are still behaving the same way. So we have a consolidated decision, and will not start to migrate the task just because we are using different ways. So the goal for us is really to use select task fair, which is right now mainly used at wake up for a task. And we would like to extend the usage of select task fair, not only for the wake up, right now it's used for the wake up, for the fork, or the exec. And we would like to use that in, I would say, in any other situation. If at some point you want to see if the current, what should be the best CPU for a task, we would like to call that even if it's not a wake up. So that's why I'd like to extend the select task fair to be used at any time and not only wake up as right now.
It's not very clear maybe it's not very clear from your slides, but this will actually give us load balancer based on power, where the same ES algorithm used to decide the best energy efficiency you at wake up will be done at load balance.
Maybe that,
really something very important.
So right now the find energy efficient CPU is only called in the select task. And in fact, if the system is overutilized, we skip the find energy efficient CPU to fall back to the default wake up mechanism. So in the first version, I tried to directly call the find energy efficient CPU for ES, which was really ES specific. And there was some other people interesting to use push callback outside the energy aware scheduler. So that's why now I'm trying to get a push mechanism, which is, I would say, available for anybody who want to use that. So that's, and the goal for me, it's really important to say, okay, use one function, the same as wake up. So select fair. It's pretty easy to extend that. That might not be pretty easy to extend the policy inside, but that's really what we want. And the main advantage with the selects is that we don't have to take care if we are overutilized or not overutilized in the ES, because we have two different policies. If we are not overutilized, we are looking for a energy efficient CPU. Once the system is overutilized, we skip all the energy efficiency policy to fall back to the default mechanism in the scheduler, in the fair scheduler. Yeah.
Do you still need the push and pull mechanism when you are overutilized?
We want to use that, yes. And one interest would be to try, when ES is enabled, it try to pack a number of tasks on some CPU. Once we become overutilized, being packed is not really useful, and we would like to spread. So right now we are waiting for the idle load balance, periodic load balance to pull some tasks. But with the push mechanism, we can be much faster pushing tasks on idle CPU, for example.
Maybe you're gonna cover it, but what events are actually triggering the push-pull?
So right now, for us, there is a, I don't know if I put that there. Yeah. Maybe not. Yeah. So for us right now, the main reason is when a task, when we are not overutilized, when a task stay for a long time on a CPU, we want to call the push callback and to see if there is a better CPU. When we become overutilized, then the goal is not to wait for the periodic load balance to push task on a more performant CPU. So that would be mainly, and for that, right now, the two proposals that I've put for us is that, so if we think the task is stuck or is stuck for a long time on the same CPU, and we are not overutilized, we use the select, the push callback. And the other solution is, the other plan is when we're overutilized, we'll try to push the task on an idle CPU.
Looks like almost like you wanted like a shorter peak decision, possibly.
Yeah.
Because I mean, for me, the difference with the RT deadline push-pull is that those events are actually triggered by wakes up, and maybe changing priorities.
Yeah.
So it's kind of similar but different, because in this case, you don't want to wait until the next wake up. You want to react.
No. Yeah. Yes, and in this case, because we want to have a short selection, the goal is that when a task is running and go back in the runnable state because his slice has been exhausted. At that time, we will check before putting that back in the runnable list if we should try to migrate the task on another CPU. The main advantage is that helps us to check only one task at a time. So we can probably have some corner case where we can stack several tasks in the list, but the goal is to have only one task at a time. So we can run the find energy efficient CPU, which is, it's not free. It's not a fast pass, I would say. So we don't want to run that for 10 tasks in the same loop, for example.
Do you have an idea of the additional overhead of trying to call that function and making a decision like quicker than, let's say, every 1 millisecond? So what's the...
So no, I haven't looked exactly of the overhead. What is clear is that we have a significant overhead. So that's why we don't want to run the ES mechanism when we are virtualized. One of the reasons. But, the goal will not be to run that at each and every tick. That's probably a bit too much. And in some case, we can have some tasks which are stuck and it's fine. We don't need to look for another CPU. The main difficulties for ES in particular will be to find the right condition to trigger the push mechanism.
So I have one concern because you're running FEEC, Fine Energy Efficient CPU, much more often, which also means it's going to run much more often simultaneously from different CPUs. But of course, we run without logs. We only have the RCU read log, and therefore there is a race where Fine Energy Efficient CPU has found a better CPU, but we haven't actually done the migration yet, as in haven't transferred the utilization on the new run queue. So, there's this race, which we probably don't want to work around because it would be extremely expensive. I feel like calling FEEC much more often, obviously makes that race more dangerous and more disastrous for the Fine Energy Efficient CPU placement.
So we can have some race, but as far as I know, we already have this kind of race already at wake up. If two tasks wake up at the same time on two different CPU, we might end up selecting the same CPU because until the task is migrated on the new CPU, it's not visible from any other thing. So yes, we can make a decision which is wrong at the time we make it, but that's already the case. And I would say the plan is that we will make more often a good decision than a bad one.
Yeah, I was just going to add on that race because we actually see that race happen like in some corner cases, but like on some, like I think with gaming, some particularly like the simultaneous wake up leading to bad performance.
Yeah.
And I'm hoping this push load balance would be a way to fix it because it's impossible to fix it at wake up. But the push load balance can happen quicker. If the wake up made a bad decision, then the other CPU will push whatever like we have packed over there very quickly and spread them around. So I actually would think that would be a fix for this problem.
Yeah, that's a good point.
Worse.
So right now for ES, I want to start with, I would say, a few number of simple cases, but then we can extend. That's why for now, I just want to call the push callback only when the task go back to the runnable. But we can also have in mind, for example, if when a task is really enqueued on the CPU, and we find that finally the number of tasks is twice more than when we make the selection, then we can put the task in the push callback list so we can migrate that directly. But it's too early for now. I think we need first to get the push callback mechanism in place, evaluate what is going good or wrong, and then we can add more use case.
Hi, Vincent. First basic question, does RT, when you have an RT task, ES is disabled?
Sorry, when we have
when you have an RT task, is ES is disabled?
No.
Then your push mechanism will not work with an RT task running, right?
No. So for now, for RT task, we are not using ES. This is only for the fair class. RT tasks are not energy aware. They are only capacity aware. So we make sure that we'll select a CPU with enough capacity for the RT task. But that might break the fair.
What happens when
scheduler.
you have an RT task and a CFS task on the same run queue? Is ES in that case works or not the case?
Yeah. That might come later. There was some discussion about making RT energy aware, but that's quite difficult and complex to make sure that you will not break the real time.
Yeah, and another thing that I think we have a lot of patches, I think, floating around with push thing.
Yeah.
And we already have a lot of use cases, for example, affinity changes, push RT, active balance. In the nutshell, they all do the same thing. They call a stopper, push the current task out. The same thing as we do is offline as well. So maybe we need a framework, for example, what you're doing for CFS, you might need a common framework per se and specify which classes you want to preempt. And maybe that can be a common framework which rest of the current use case also can make use of.
Yeah, we can probably, so the fair push callback mechanism is heavily inspired from the RT push callback mechanism. So that's why, for example, we are using the priority list, where we are reusing some of the.
And RT has similar list, right? They also have a pushable list.
Sorry, for?
Even
Yes,
RT,
for the
there's
RT,
a
yes.
pushable
But for
list.
example, for the deadline, they are using a red-black node. They are not using, so that will be, I don't know how much we can make common to make that quite generic, but that's probably something we can have a look at, yeah. But maybe, yes, okay. Maybe we should first have a push mechanism that works for FAIR, and then we can make a generic one for everything. But yeah, I agree. And that's another thing. I mean, I'm using a static key. I'm not using a Boolean, but just a normal one. So that right now I'm enabling the push only for EES when EES is there. But the goal is that this can be enabled for any other feature. I know that there is a number of other features that will be interesting to push task on another CPU. So that's why I have tried to make sure that what is there is not only ES, but FAIR as a whole. And there are other features that might be interesting to look at for the push mechanism. Yeah, and I think that's all. I don't have much more on my slide, to be honest. My goal was really to understand if that makes sense for everybody, if there is other use case. I know that after my session, there is another session about push mechanism for the FAIR scheduler. So at least I know that some other people are interested in. I don't know I haven't looked in detail. Yes, there is a question.
Is it safe to call this function when you remove the task from the L list, when you're waking it up?
Sorry, when?
Like you have the L list, the linked list,
Yes.
before you put it in the run queue. Can you call this function at that point when you're removing the task from the L list?
So yes, that should be, yeah. We are taking.
There's no locking problem or anything like that. You can just call it.
So no, we are looking. We are taking the lock of the task while we are evaluating where to move, but that should be okay. We are doing that just before putting back the task, running the put previous task. So yeah, that can be called. The goal is to call that, I would say, at any time. The callback is only called after the switch happened for us. So when the switch between the previous and the new task happened, at that time we are looping in the list of a task in the push callback list at the point. But then otherwise that can be called, I would say.
Okay, thank you.
Okay. I can't remember what I wanted to say, but is there any other question?
Yeah, can you hear me, Vincent?
Yeah.
Yes. Yeah. In terms of testing, I was trying to understand or reason about the T-bench test results you have in your patch set, and I think you were saying you could also the benchmarks or some RT up snippets, where we can essentially see the functionality in action. Because one thing I'm a little bit afraid of that. We now have the push mechanism, and then we have load balance, and we have EES and non-EES. So there are different mechanisms fighting in different scenarios, like overutilized and not overutilized, blah blah blah, maybe against each other. And I wonder what this does to performance numbers of workloads. And with EES, it's essentially performance and energy consumption. So where do we? Is it feasible to create some benchmarks to verify this for a broader audience and not for a specific use case in Android?
So for now, I run a number of functional tests with that to make sure that it was working. I made the mistake to make some small change just before sending the patch, and I broke up one of the patch. So that was disabling the ES mechanism at all. So that's why the T-bench result is just garbage.
Okay.
And that's why I mentioned that in the new version. So I have a number of functional tests for that. And I have started, but it takes some time to try to run some tests with the Pixel 6 and the Android mainline to get the real use case. But for now, I don't have any numbers to share.
Okay.
But for now, it's mainly some functional. Yeah, I have to stop.
Yeah, we fixed some of the issues and we run it on different platforms already. And just to get familiar with this stuff, I think one thing we noticed is the mechanism might work on one board with the same kind of test scenario and not on the others. So because the capacity and the energy models, they also might have something to say here to essentially evaluate if this is successful or not. So it's pretty complicated, I think, from a testing perspective to say this is good or not. Like always on heterogeneous systems.
Yeah. Okay, Dietmar, we can probably discuss that more deeply after because we have to start the next session. But yeah, I will be happy to discuss that in more detail if you want. Thank you very much.
Thanks.
You can come. I think it's your slide.
Yes. Okay, great. Thank you. Hey, hello, everyone. So more discussion on pushing mechanism and more use cases for fair tasks. Except for in case of ES, we are trying to not hit the overutilized threshold and keep things in the ES world and not go to the load balancing world. In my talk, I'd rather talk about leveraging the push mechanism to proactively load balance when you know that there are idle CPUs somewhere and you know you are overloaded with one preempted task. And it could be a while before you start exploring the load balancing because the load balancing period scale with the number of CPUs in the domain and your domain could be very big. And you may not even decide to look at an overloaded CPU for a while. So is there a better way to do load balancing using push? Since we are doing this from a busy CPU, we don't want to take too long about it. So the basic requirements are we need some cheap indicator that says that, hey, there is an idle CPU. We need some fast way to look up this idle CPU. And we need a bailout mechanism just in case things starts failing because of affinity reasons or something else. Before we go to the push mechanism, there are a few preparatory patches that I want to get some feedback on. One is the optimizing sched domain shared assignments. Now, the problem is, if I start using the sched domain shared object for keeping track of idle CPUs, I'll end up bloating it with a CPU mask. And we probably don't want to do that because we allocate a sched domain shared object for each domain during HDT alloc. And then if we don't use it, we end up freeing it. So is there a better way to optimize the whole thing? And there have been patches floating around where we are trying to do this on the Arch x86 side where people say that, hey, we know that SMT domain is not going to be used. Do we even want to send it to the generic sched layer as a domain when we know that it's going to get degenerated anyway? So what I have in mind was we'll have just a single layer of HD shared object. Given that we know only HD LLC shared is used, we assign it to the topmost domain when we build it. And anytime there is a degeneration, we just pass it on to the child domain. Because we know that the LLC domain can't overlap. We know that the child domain span has to be same as the parent domain span if it's getting degenerated. And so far, I have not run into any trouble with this, but are there any concerns where you see that this passing down mechanism can fail with SCED domain shared objects? Okay, nothing heard. So I think that's good then. So, Valentin, you're not here, but passing down the SCED domain shared object. So instead of allocating it for every SCED domain during HDT alloc, freeing it up when it's not used, can we instead just allocate one set of it, assign it to the top group, and pass it down if the top group top domain gets degenerated? Is that something that can cause any problems?
So in your case, the goal is not to have the shared domain attached to the LLC.
No, only the HD shared of the LLC is ever used for the sysutil, for the no head idle balancing mechanism. But we also keep it for cores, we also keep it for clusters, and we just allocate it without any checks. We just say that we'll allocate it now, and then we'll free it later on if it doesn't get used. So we'll not even take the allocation overload.
What I mean is that you don't care anymore if you have a last level of cache or not. You just always have this kind of shared domain where you will have the CPU mask.
So I allocate one per CPU array of it.
Yeah.
I don't allocate it for every domain. So for each HD, I just skip that. I allocate it once. I assign it to the topmost domain. So that is the HD LLC shared. And if it gets degenerated, then it gets passed down. So I don't say that, okay, this HD shared is no longer used, and I'll free it later on. I'll just pass it down.
But I mean that we'll have only one shared object per CPU.
Yeah, that's it. Because that's the only one that is being used. Others are just being kept around, wasting space. And now that we have a decent number of cores in the system, some space to be had back.
And just for the cache aware, they are not using the shared domain.
They're still using HD LLC shared, but none of the other domains.
The same.
Yeah, just the one.
Yeah.
So I guess that's okay then. So one more thing that Peter brought up at OSPM was, I was planning on using the no head idle CPU mask to see which are the idle CPUs where I can push tasks to. And what Peter brought up was, hey, this is a global mask. It gets shared by all the CPUs. Any CPU can set itself on it. And then there are other bunch of no head global variables that get changed every so often. So can we break this down? Can we break this one whole global mask into a per LLC masks that then is not contended as much? And if you're reading it, you're reading the LLC local mask, so it doesn't get bounced around too much. And I had two implementations in the mind. Peter had suggested that we could have these per domain signals where you just set an atomic bit up top saying that, hey, something below me has an idle CPU. But what I found out was that scales with the number of groups. You need to somehow know that these many groups below me have idle CPUs in them. And with a deep hierarchy, you can kind of scale your number of atomic operations to go all the way up top. So instead of that, what I have actually implemented in my RFC series is you have one global indicator that says how many LLCs have idle CPUs. And then you have a chain of these HD shared objects that also now has a mask that says that these are the no head idle CPUs within them. And all the users of the global no head idle CPUs have been converted to use the shared list instead of going through the global mask. The global mask is easy because it's just one mask. But now we have a list traversal plus a mask. But all of this is being done from an idle CPU's context, which is not yet busy. So I believe that should be okay, right? Or is there any concerns? Yes. Yeah, because Cadex has already done this before.
Yeah, I want to mention how do you map the proximity? For example, if let's say we do that per LLC.
Yes.
but you may have like the different topology where an LLC is more convenient than another.
So this whole list is only used for idle load balancing. At that point, we want to go through all the no heads idle CPUs in the system and balance them anyways. So I was suspecting the order should not be a problem because being done from an idle CPU, so we are not making anyone wait. It still appears idle, so wake-ups can still happen on it. And all we are doing is we have to traverse all the idle CPUs. So that shouldn't matter based on
that makes sense. Yes. Yeah. Thanks.
The concern was with the cache line bouncing, right? That no hertz idle CPU mask. So I think that's okay if you have LLC size which is small, but these days trend is like LLCs are becoming bigger and bigger.
Correct.
Let's say you have two LLCs per NUMA node, right? Or a node. So then you kind of have the same problem because you are traversing the whole list, and the remote CPUs can be doing the write as well, right? So
it is possible, but we are only looking at one list.
So do you
element
bail down? You bail out. The moment you find an idle CPU, or you go through the list anyway. Like
when you turn busy, you bail out yourself. So the list traversal ends. If you find that a CPU on the list that is set idle is not idle anymore, you bail out doing load balancing for them. But otherwise, you go through the whole sched balance domains functions for all the domains that CPU has. So instead of taking that entire global mask and bouncing it around, because if we use this for push mechanism, then it will bounce around a lot more and any CPU can basically write to it. But if I'm only saying that I'm going to look at my local LLC's mask frequently, and the only time it is going to go out of the LLC is for the idle balancing, then I believe the contention should be reduced.
Yeah, so just for me, so at Wake, for example, we are looking at an idle CPU at the LLC level. So the goal would be to only look at one element of the list.
Correct. But the problem there is for the normal wake up, we are going to the sched domain and doing the idle CPU function, right?
Yeah.
That only cares about whether the CPU is on the idle task and we don't have any pending wake ups. Problem with no heads CPU mask there was you only set the CPU on the no heads mask when you go idle and you want to disable ticks. So you don't have a tick running.
Yeah.
And you only clear it out when you exit out of idle and you hit your first tick. So that kind of reduces the overhead of setting the mask and removing it from them. What I have also tried out was have another parallel mask, set any idle CPU, any CPU that goes into idle, clear it out when it exits idle. That unfortunately, even for a very small 8-core LLC, is very expensive. You can noticeably see the benchmark regressions. So again, that was no go. I tried that out. Other thing was maintaining a list of overloaded CPUs so that other things can be done faster, like pulling the task. Just maintaining the masks have turned very expensive. So that did not scale, unfortunately. Yes.
The idea here is basically like you want to basically speed up the push if the CPU is overloaded and we have idle CPUs basically.
Yes.
So why not the new idle balance is helping us here? Because I thought the new idle balance should be doing the same thing, which is speed up the pull.
Correct. So new idle balance does a pull. There are a few places where it does not. It fails to basically find an idle CPU. So once you go, once you're past new idle balance, then there are no other opportunities for it to again repull the task, right? You may suddenly have a wake up somewhere else. And there is also the fact that new idle balance is being done in the previous tasks context. So RQ cur has not yet been switched to RQ idle. So any wake ups that is looking at the LLC and a CPU that is doing new idle balance will not appear as an idle CPU to it. So it will not proactively wake up a task there. It may wake up somewhere else. And then later you realize that, okay, this CPU has suddenly turned idle now after new idle balance, but it has raced with this wake up.
Basically, we have a wake up and a new idle balance happening at the same time.
Correct, yes.
But is this targeting this specific like race condition?
It is also that, and the whole point that if you want to look at the larger domains in the idle load balancing path, each CPU has to wait for like on a 16 CPU LLC, it has to wait for at least 16 ticks. So on a
Yeah, but I think that's the problem because like I think these stuff like I've been complaining historically been there. Are they correct waiting for 16 ticks? Does this number make sense? Should they be lower? I think that's
so
the question.
there is also another side of the problem where there are these very specific EDA set of people who they don't even like having the balance run. So they're like, okay, you do all this balancing work only to find out that, hey, there are no overloaded groups. And what you are wasting, the number of cycles you are wasting in kernel, we could have at least run it in the workload. So we have also those set of people who say that, hey, once the system is like completely balanced, we don't want any more balancing activities. And there are those two schools of people at that point. Where if you want to reduce this interval, they would be like, hey, our benchmarks are regressing. If you increase the interval, then there is a period where your system can be imbalanced, but you're not doing anything about it.
Yeah, I don't know. Like for me, like this will introduce the same problems. It's just done differently. Like if you force the new idle balance to push like sooner.
Correct. So an ideal world would be you are a busy CPU. You know that there's some very cheap way to trigger a new idle balance on some other CPU. Like you just say that, hey, anyway, you are idle and you are not expecting to get woken up. Why not just start a new idle balance given that I know I am overloaded? And that way both win. But it's very hard to send a signal. Like if a bunch of CPUs are going busy, it's very hard to set a signal to one particular idle CPU and say that, hey, you do this whole job on my behalf.
So in this case, would this can replace, we have the new idle load balance and we have the idle load balance.
Correct.
This would be a way to replace idle load balance at all in this case?
In this case, it should be possible, yes. But yeah, that's the ideal word, because I told, right, the CPU masks, maintaining them itself is becoming an overhead, and then the busy CPU has to traverse the whole mask. So once you go beyond a certain domain size, you get diminishing returns, because you may at some point, a lot of busy CPUs see that there are idle CPUs in this domain. They all start idle or try to push at the same time, and by the time some CPUs are done, they realize that there were no idle CPUs because someone has already called dibs on them, and that overhead adds up.
Okay.
So we can't traverse the entire list of idle CPUs. That becomes a bigger overhead.
And in this case, could you split? I mean, in the idle load balance right now, we are going through all.
Yes.
Can we, in this case, delegate the look for an idle load balance in the same LLC, so you are contained, and then let the idle load balance, the periodic idle load balance, to look at a wider scope?
That should be possible.
Okay.
So each CPU takes care of an LLC, but for a bigger idle load balance, one CPU takes the turn to do.
Okay.
I'll try exploring that. So those are the preparatory patches for the push mechanism. And those are the things that are actually in a decent form. So with the push mechanism, we are in the experimental territory where we know that, okay, we can try this out, but does it work? And the answer is, okay, it works sometimes. And when it works really well. But when it fails equally badly. So the one problem that I mentioned was the no headset idle mask. It is only set when CPU is going tickless idle, and you only clear it off after a single tick. On a server that runs at headset 250 generally, that's up to like 4 milliseconds of the CPU being busy and still being set on the mask. So you have this period where you know that there might be no idle CPUs, but it still appears on the mask. So CPUs may still do an idle balancing. Not ideal. Other thing was to say that, hey, can we maintain the whole, all the idle CPUs in a mask the way SCADX does. That was found to be too expensive, even at a per LLC level on the server. So only maintaining the mask, not even like using it. You just set the CPU, clear the CPU, only those operations. Contending across the LLC takes a lot of cycles. One more thing that I wanted to get some idea on is we are using double RQ lock for push, but we also have this TTWQ wake list, which queues it on the wake list and sends an SMP call function. RT folks don't use it for latency reasons, I believe. But is it possible for, if on non-preempt RT, we can use this for the migration and other load balancing path, where we know that the target is idle. So queuing the call function is offloading your work to this idle CPU. So is it better that way? Like even in the normal load idle balancing, you detach task and you leave the attached part to the.
But in this case, why not going a bit above? Because we have this right now. If we are on the same cache level, we are using that. Otherwise, we are falling back to the default mechanism.
Correct.
So why not calling at this level so that will work with and without preemption?
Okay, that's something.
So either we fall back to the current mechanisms where we are looking on the local CPU.
Correct.
And then enqueue and activate, or if we're on the same cache, then we can do this wake list in this case.
Correct. So that is possible, yes.
Yeah, I mean, as Peter mentioned, we probably need to rename that because it's not try to wake up anymore.
Correct.
You probably have to
get a generic name going.
Yes, to make it work.
But yeah, just wanted to know that whether that idea sounds good of using the IPI-based offloading for idle CPUs. When you know that something is idle, why don't you do the work for me? From at least from a power energy standpoint, I would like to know, because that's waking up an idle CPU for doing some work.
Yeah, but I think we need to keep the current mechanism.
Yeah. The switch needs to be there in case we want to disable it.
Yeah.
And yes, so the last thing I wanted to talk about was the bailout mechanism. And the problem there is there can be these weird affinities where you're assigning it to a core, but that means there are two CPUs and you will still put them on the push list. But at that point, you realize that, hey, you can't push it to more than two CPUs and you bail out. So one thing there, what I found was the piggybacking on Shenyu's sysutil, it actually works pretty good. So having the bailout threshold periodically refreshed to the NR idle scans for the push mechanism seems to bring down the overhead. So that's also probably something to consider. Probably not for ES because you look at all the CPUs, but if there are affinities involved, you may end up wasting a lot of cycles because the same two tasks keeps getting preempted every time. Yeah. And yeah, food for thought was if we have delayed tasks that we are finding during load balancing, should we directly block them or should we take the overhead of migrating?
I'm not sure it was trying to push a delayed task because it's already trying to sleep. So you'll.
No, in the general load balancing path. If we know that this was a delayed task, you're looking at the list, but you find that at that point it's eligible. Should we just block it and let the wake up select whatever CPU it wants? Or do you want to move it to another CPU and let the pick dequeue it? And yeah, with that, I'm out of time.
Yeah, I don't have any good answer. I'm not really convinced right now to the fact that when we are doing load balance, that we can, if we are overloaded, we take a get delayed task to migrate that on another CPU because at the end that will just be sleeping on the other task.
Okay.
But I think we should not try to play too much with delayed tasks.
Yeah, just some food for that. Yeah. That's my time, guys. Thank you.
Yeah. So it's the break slot for now. We have 30-minute break. 30, yes? Yeah. So see you at 12. And we'll start with the next four session. Thank you.
Right. Well, and this is how I'm using the GPU is one of the things this could tell me.
Oh, tonight? Yeah. It's two. you know, he gets here in like a day, and it's like, I really would prefer for you to get here like Saturday morning, so that I can just talk to myself and I can tell him. But no, I was by myself, it was terrible. It was so heavy too, yeah. No, since I was it's gonna take several days to go, so I had to do really fast. Because they have those little ridges, like, I don't know, I think it's just not skateboarders, I don't know why they're there, but instead I just like, I would roll my suitcase and then it would start falling forward, and I could deal with that. Oh, okay, yes, yeah. Yes, there are the ones that go in the middle. Yes. One thing I've been amazed by here is I keep seeing people scrub their hands. Really meticulous about cleanliness. For safety? Yes, yeah, we used to know for it, but I don't know how they do it. Oh, yes. That's true. No, I have heard that it can be. Yeah, you're gonna get for a 60-hour work week. What's your jet lag? Yeah, I was thinking about that. Yeah. Yeah. What time did you start? Yes. And Sean, you're such a fresh you rush. Yeah. No, I mean, say sorry. I just love the idea of freaking out. I guess. Yeah. Yeah, amazing. I'm really stoked for that. Yeah. There's like 3 days of work that I'm doing. It's like, okay, let me fix all of these problems and issues that have like popped up. Yeah. It's done. It's done. Yeah. Are you okay? So you're planning on the other conference. Do you want in the comparison? Yeah, you're tiny. I'm gonna be. No. I mean, I'm not gonna listen. I'm gonna be like, just a second. Yeah. Actually, just 1 second here. Yes. I'm having this conversation. Yeah. No. Yeah. This is basically from the course. Here too. So this word.
I think it was not part of the data. Like, I don't know if you went, okay, I think Red was there. And Alex talked to him, and he said, yeah. So we took it,
Just because I'm feeling this. I mean, I have that. Yeah, we did. Okay, yeah. Yes. No, it doesn't. The geeks can't be the owners. There were at least 3 of these that were much more. So that's like, fuck you. Please keep fucking this.
What is it that just uses like links from just announced Luna? So like it's the new all the links.
Yeah, I know.
Yeah, I think this is like a new one. I have no idea. I just read the headline.
I have voted for yeah. And there are some he's judging.
So I went to this kind of place when there's a couple of they were like, yeah, basically like, how did you find this place? Because they were like, yes, and they have this like that. They were like, yeah, that's honestly not familiar. The problem is that because of the yes.
I did. Just to make sure, I didn't. I am on
Daval, do you remember which one is the next? Okay. Sorry? Yes, normally, yes. Runtime verification for real time. No, it's Gabriel. That's another one.
That one.
This one. Okay. Hello.
We should wait a bit, right?
The main problem is that it's time, and we have some. You're waiting for someone in particular.
There's Sebastian, but he's not here.
Yeah, yeah. You can have a look. Yeah, he is going to look for.
Yeah.
So, in order to change it there, you can move your slide. Okay.
Thanks.
Okay. Oops. Yeah, okay. So I'm Nam from Linux, and today I will be talking about runtime verification monitors for real-time application. So first, let me explain a bit about the background context, why we are doing this. And the reason is because now PRMRT is mainline, so the kernel is real-time capable, but very often the user space application is not, and the system is not really real-time safe. And the problem is usually always one of these three, something like a mutex without priority inheritance, so we got a priority inversion, or user space do not lock the memory pages that the real-time threads use, so we got a page fault, and handling page fault takes some time, so that can be a undesirable source of latency. And user space also usually have no idea which kernel API that can be used for real-time reason, and very often they use the wrong thing. For example, they use TimeFD for real-time cyclic tasks, and that doesn't work. So the idea is we make some kernel runtime verification monitors to detect these common problems and report it to users. And the way it works is the monitors will use the kernel trace points to verify one of these rules. First, the real-time task should not be raising page fault. And second, the real-time tasks are not working by a lower priority task or soft IRQ, because this is a hint of priority inversion. And also, when a real-time task is going to sleep, it must be doing clock nanosleep using absolute time and monotonic or Thai clock, or it must be full text wait, or it must be equal wait. So if the user space thread doesn't do one of these, then there could be a warning. So the question I bring it here to this discussion is, are these rules complete? Is there anything missing from these, or is there anything incorrect? And the first one I want to talk about is full text wait, because I had lots of debate with this, and I think maybe we should use full text PI instead. And the reason is because the glibc implementation of pthread mutex without priority inheritance, that one used full text wait. And we want to warn that because mutex without PI is a problem for real time. We do not have to do that, because look at the rule again. We have the second rule, which is real-time tasks are not working by lower priority. So if a real-time task you mutex without PI, then this can eventually happen and we can detect it eventually. But the problem is when user space use mutex, it may not always have lock contention, and a wake up may not always happen. So we want to detect a mutex without PI regardless of whether there's contention or not. So because of that, I think maybe we should warn that about user using field weight. But on the other hand, the realistic implementation of pthread conv weight also use field weight, but the conval looks fine for RT, so maybe we shouldn't want that. Yeah.
Okay, so right now a lot of this is policy.
Yeah.
You're basically policy driven. Would it be possible to create a tool of some kind, user-based tool, that you think, if someone's going to say, hey, I have an RT task or something, and it would show up like a dialog box, or maybe it's even a web browser type of thing, and it says, okay, here's some characteristics. Describe the characteristics of your real-time task.
Mm-hmm.
Do you have, basically ask these questions? Do you expect this to happen? Do you expect that you'll never have questions to the person that's going to run the real-time task that will describe how they want their task to behave.
Yeah.
And then it will create the module and the runtime verifier and install that based off of the information, create the DAG and everything, based off of the information that the user supply. Instead of asking kernel developers of running this, do you think this is possible? It's because honestly, we don't know. The user will. It sounds like this is a policy question for the user, not really the kernel developer. Does that make sense?
Yeah, it does make sense. So I think the problem is that we're trying to help people who doesn't know how real-time work. And I think it is hard to ask the policy from them because they have no idea.
Right, well, that's what I'm saying. You have to kind of come up with the questions that are more like layman questions. So hey, do you have what threads do you, or what processes do you have that are woken up? I don't know exactly who the user is, but or you can say how level, how strict do you want your detection to be? Maybe have a level, and if they say, I want to be super strict, and then basically maybe they do this, and then it will show a warning, and they look at it oh yeah, I guess we do have a real case for that, and then they can adjust it. Yeah.
I think that works really well if you're having a complete real-time application. Where it doesn't work really well is, hey, I want a real-time thread because when it's my time to run, I have to run, otherwise my entire system is going to go down. And those guys are not very good at describing or understanding what their interactions are.
I always go back to my old talks where I talk about real time. I always say real time is hard. So it's the question is, well, again, I'm also going back to my contracting days where I would talk to people and say oh, I want real time to make it fast. I'm no, you don't want real time.
I don't disagree with you. We have had many, many talks over the years on why you shouldn't be using real time. But the reality is when you sit down with them and you go back, yes, they actually have requirements that actually are probably better handled with deadline and not real time. But deadline is also really hard to do. And real time just gives them an easier way to make progress.
So can we go back a slide?
Yeah.
Where's your questions here? So for instance, here, I'm just going to pick on one. Okay.
Mm-hmm.
You can't have maybe it's back one more. Back one more slide.
One more?
Which one is it that says a task can't be woken up by a lower priority task?
Oh, yeah.
Oh, yeah, sorry. Yeah, so this brings to mind the question, what's your definition of real time? And what's the definition of real time for the user of this thing? And I guarantee you my definition of real time is different than yours, okay? And it doesn't matter what that means. It just means that this is an unbounded problem, okay?
Yeah.
So if I'm trying to do something where I have a DSP task that needs to run on a deadline schedule because it has to process a certain amount of things, that's completely different than when somebody is saying, like you said, I need a task that runs fast. Okay, that's not real time, right?
No, that's not. That was us correcting. That's what the customer tells us. I'm you don't want real time.
Right, sure. Here you go.
Oh, sorry.
Exactly what you're talking about, right? Hey, I need to run by this time. Maybe it's a heartbeat process. And now I'm just going to trigger a reboot. right? So if you don't run, if you don't, pet the watchdog, you're going to reboot. So
One like kind of use case where like that RT task not woken up by low priority tasks or soft IRQ. A legitimate example would be, say, if you need something has to access a device that has some real-time requirements, and so you wake up the thread to do. So you'll have something that wakes up a thread that's real-time to handle the real-time requirements, but the thing that wakes it up isn't real-time.
Yeah.
So that's a legitimate case where even though like the thread that's real time will be it's going to be a service thread, but the reason why it's real time is because it's got to access something that has strict requirements, deterministic requirements. But it waking up is not deterministic. How it gets woken up is not deterministic. So that's why that should not be a hard rule right there.
I sent you an email. I should have followed up on that. I did not, but I think this talk will cover exactly that. One of the things that we want to sit and probably figure out is, hey, if you are doing X, Y, and Z, you should not be real time. And I think that's kind of what will help over there. Ask Yuri, right?
No, I mean, so basically, first of all, I hate the term real time. So I always say real time to me is more deterministic. And my joke, I always say it's a deterministic operating system, or DOS, and which is the original real-time operating system. It was, whatever. But anyway, the definition is if you have hard deterministic requirements where you can't have outliers. That's basically the definition of real-time, is you can't have outliers. I always tell people real-time is the fastest worst-case scenario you'll get. That's what I would say if you want to define the layer. So if you have any task or anything that have like hard requirements that can't be outside a window, that's real time.
Trying to go someplace with that. So if you're trying to build a tool that determines that this fits into the Linux model of real time, right? Then you have to start with a definition of what you're going to achieve by doing that, right? Yeah, here you go.
This is kind of a going saying that, hey, I have only these small set of use cases that I'll support. And I can guarantee you users are going to find a way to abuse it. So, yeah. I mean, I think what he's trying to point out is that this would not, you're trying to verify saying, hey, you are not going to meet your requirements here. I think the harder problem is just trying to get people to define their requirements and point out that this is probably not real time.
Yeah, I agree. I think one thing that usually misses is like a design phase of the application or what you're trying to achieve. So if you went through a design phase, then you probably have a model of what you expect, and then you can use the model to actually verify that this system is actually doing what you expect it to do. In reality, at least my experience, the design phase is mostly completely missing. So people are assigned priorities and they expect it to work as they think, but that there is that missing link. And I mean, something like this should help with that, but still we would require a design phase before this thing.
Hold on a second. I just want to bring up that I'm not so sure if you really described the runtime verifier at the beginning. You kind of just went right into the thing, which is fine. I don't know if you're familiar with the runtime verifier?
And right from the very beginning, all the different Linux approaches, I just looked at them and went, yeah, not for me. That's like 15 years ago.
So, but I'm just saying, but the runtime verifier, what this is a utility that actually guarantees that the operating system is actually doing what you're expecting to. And if it, so you have these are requirements that goes into, and it monitors the operating system. And if it ever breaks any of these requirements, you get either a print, crash, warrant, it turns on a reactor. So I just want to let everyone know that's what our runtime verifier is.
And then the other thing, is what I have noticed over many, many years is I studied with Yuri, so I have some theoretical background in real time. One of the things you do with real time is you actually spend a lot of time trying to figure out, can you run this or not? Can it be admitted into the system or not? Is it going to meet the properties or not? Most folks are like, I have to run this, otherwise my system's going to go down, and we're going to run it. And then they get confused why it doesn't work the way it does. What doesn't also help is Sketfair has nice, which is not priorities, but real-time has nice, which is priorities. Yeah, sure.
You have to go back and ask me what's your mission. So that's what this is for. Yeah.
Well, I mean, now what this tool does is not make sure that the user space application meet whatever the real-time definition is. But what I want to do is, people always ask us why their real-time application does not do what they want. And usually it is always one of the same reason. And we want to detect those. And maybe we can, sorry?
I guess you're trying to find general rules that kind of always apply to any kind of real-time application and check against those.
Maybe we can also just define all rules that can potentially be a problem, and then people can disable what they do not want in the application.
So I go back to, I see where you're coming from.
The Runit?
No, what? No. I mean, what you're trying to do. But I'm just trying to see, like, I have dealt with real-time issues with Oracle DB, with a couple of other applications, and then another application I'm looking at right now. And every time I see, I cringe, right? Because you don't really need real-time here.
Mm-hmm.
I think what you are doing here is when somebody says, we know for sure we want real-time, and we're not getting the behavior we want, getting stuck there.
Yeah.
And I think there may be two different problems. I would be a little more interested in solving the problem of you're using real-time, you're not getting what you're expecting, and how do I tell you whether you actually need or do not need real-time?
The thing is actually, people sometimes forget to use prior to inheritance mutexes, and then they block for a long time. And then it takes them a long time to figure out that they did the mistake. So blotting on mutex wait is like a thing to figure it out very easily that this is wrong and you made a mistake here. And this helped people quite some times. But then you run into the thing that the conditional variables do the same thing. And we cannot whitelist it. And ePOL is now on the good side, simply because NUM fixed it a few cycles before. But ePOL was bad before that as well. So we taught people to use POL. No, POL was bad as well. No, POL was good. I don't know. Doesn't matter. The thing is, ePOL was bad. But now ePOL is on the good side, right? So that switched. So now we can whitelist that one and say, this is good, right? So this is basically what side of API can be used and what not. Because some parts of the API is not real-time safe. Your application might be, and you might need real-time for good, right? But not every API is to be done. For instance, memory allocations. You don't want to do this in your RT thread because you can block for a very long time, right? So if you know this, all good. But if you don't, you might need some tooling or documentation. And this is the tooling side we work on.
Yeah, as you mentioned, there's lots of kernel API, and there's no documentation describing which one can real-time use. And people just use what functionally does the job for them. For example, I know Pipewire used HammerFD, and yeah.
See? Would you be able to say HammerFD is a good thing? And I would ask you like 5 minutes ago. There is no way of clearly saying HammerFD is good or bad until you see how it behaves. Most people from userland cannot say yes or no. So this tool should be like a guidance. Don't use this or that.
Maybe if you're So maybe if you're trying to do a runtime verifier, right? What you want is some kind of logging of what it is that caused me to miss my deadline, right? Something like that, as opposed to, yeah. So, one? Yeah, go ahead.
No, I mean, that's exactly, it tells you what your application is doing wrong, and I know where time's up, but we have the whole tracing thing. You actually stop tracing infrastructure. You can see what caused you to miss your deadline. Anyway, thank you.
Okay.
So the next one is, I think it's this one. Yeah. Okay. All right. So hi, I'm Gabriele from Red Hat, and I'm going to talk again about RV, Runtime Verifier, but it's a bit on a different, let's say, on a different view. Yeah, you're right. So in this case, we don't want to use the Runtime Verifier to validate the user configuration or how the user is using the kernel, but to validate the kernel itself. And this has been actually the idea that led to RV in the first place with, well, this is one type of model, but the deterministic automata was the first type of model that was there. So it's, well, for those of you that are not really familiar with deterministic automata, those here are not really deterministic automata, but they're kind of like. And they are simple state machines where you have a state that is the current state, and the next state in the state machine is determined only by the current and the event that occurs. This is a very simple model, and one thing that actually you might have noticed from the presentation before, when we have RV, we are at runtime. So if there is a problem, we need that problem to verify. So it's not static analysis that we will spot everything, that we will find some kind of mathematical proof that things don't happen. But nevertheless, we can find a lot of bugs with this kind of idea that would not be possible to be found in other ways. Because if we are in a state and we get an event that is inconsistent, this will lead probably to a problem, but we will not see the problem unless we are there on those events. So this is sometimes very helpful. What are we trying to do now is to add something more to that, as well, we are making them hybrid automata, so it's a new type of model that essentially is adding constraints. And the interesting part of this is that those constraints can be on real time. And here by real time, I mean time like nanoseconds or GIFs. So we can actually say in this model, the one on the bottom, that deadline tasks can run only when they have runtime. And if they do run after runtime, then there is a problem in the code or something is wrong. So we can really see those kind of things. So now, actually, I wanted to ask a bit of a question to the audience, because in here we have, we are working on validating the deadline scheduler in this way, deadline scheduler and deadline server. Deadline server is kind of a moving target at the moment. So it's continuously changing, and we are trying to adapt and trying to validate it by the time. We were successful in finding bugs, actually, once that got updated. So that was actually nice. In here, you see a very, well, reasonably complicated example. And this model is only on the deadline server. And all those events are, well, they are all trace points, and they all receive the deadline entity of the deadline server. And we are trying to move around in this model by thinking right now the assumption is that we have just one deadline server. This is no longer true because we are going to have soon another deadline server, so for Shed X, and we are actually going to have almost soon as well some hierarchical RT servers. And this is going to break a lot of assumptions in this. So first of all, I would like to know from you if it's something, since another thing here, we are not running in the scheduler. So we don't really have access to all the scheduler facilities, to all the data structures and stuff like that. So sometimes we need to kind of infer from the trace points what is happening. So for instance, in here, we can be idle, and we know it because we switch to idle. That's the only way we can know it. And we are no longer idle when we see that there is a wake up, for instance. So we can't really know what is in the run queue at the moment. So
isn't there trace points in the scheduler that you could use to?
There, you mean enqueue the queue trace points?
Well, yeah, I mean, I'm talking about trace points, not trace events. I thought Peter Zylstra is okay if you to add trace
Yes.
points that are not exposed to user space, because I mean, it's exposed to the runtime verifier because it's a module, but other than that.
Well, there was a thought actually that was not merged, but NAM published a patch for enqueued events. Those
Okay.
will help actually.
Okay.
But still, like, we need to track all enqueued events. This is not a big problem at the moment, so we can kind of handle it. The problem is that once we get one of those events, we know what enqueued, so let's say a fair task, so we can assume, okay, this is the fair server that is at play. But we don't have the fair server. So we need, here you see this table is basically saying, based on some events, we might have information. In some other events, we may not have them. So if we have a replenish, that is a trace points attached to a deadline entity, so we do have the deadline entity. But if we have a enqueue or the queue, we won't have the deadline entity, so we will need to pick it somehow. We can store it, that is not a problem, but what the problem is here is that, what problem? I would like to know if it's something acceptable to store in the deadline entities what type of server we have, or some kind of way how to understand what type of server is that. Because currently, okay, there is just one server, so we know that's a fair server. If there are multiple types, then we need to kind of understand. And at the moment, the only user of that field would be the runtime verifier. So I don't know if this is something that we want to export.
So wait, where do you want to?
Basically, we receive the deadline entity in those trace points. We don't know if that deadline entity, or not always, most of the times we don't know if that deadline entity is for the fair server, it's for the ShedX server, or is for another server.
Right. So
yes, you need an additional maybe field in the deadline entity.
Yes.
A type field.
That would be the simplest solution.
Okay, real quick, but instead of having the deadline, I mean, could you add it to the trace event, like the type to the trace event itself, or is it?
Yes.
In that way, I don't know if you want to add a field to a structure that's going to be saved for everything, but if it's just the when it's executed, because if it's a no-op when it's not enabled, so you're not adding any overhead or anything,
Right.
but adding a field to something that's taking up memory, if it's only one user that may never be used, I'm usually against that.
Yeah, exactly.
But why the type matters so much?
That's the thing, because in this event, replenish, start and stop, we have the deadline entity. We may not care what type it is, but in other cases, for instance, the resume or enqueue, whatever, we have a task, but we don't have the deadline entity. So we know that that task is fair because it's fair, but we will need to pick the proper server.
But but isn't enough to say this? You want to distinguish between a server and a different entity, right? So
well, not only that. I want to know what type of server is this.
Okay,
if it's
so
a ShedX server, I want to know it. I cannot say, okay, it may be ShedX or it may be.
Yeah, okay. Because you can already distinguish between a server and any other entity in a task.
Yes, that you can.
But in addition to that, you want to check like if it's a fair deadline server versus a SCADX deadline servers versus potentially any other whatever deadline server. Okay, I see. And yeah, of course, I mean, you can check the pointer, but it's ugly.
Yeah, well, you don't always have the task. That's the thing.
Yeah. Okay. Okay. I
If
see.
you had, and that's the only one where I marked all of the ticks. When you boost a task, you know that's a fair task. It's boosted, so you have also the deadline server. So in that case, you know everything. But that's the only event where you really know everything.
I see. Okay.
But one way, as Steve said, actually, we could pass it to the trace point. So this would be one way. Another thing, actually, right now we are assuming that there is, at least per type, but per CPU, there is one server. But I think with the hierarchical servers, that's going to be different. So we will have one per C group, right? So this is going to change a bit because let's say we resume a task. This is a real-time task, but what C group does it belong to? That's going to be... Yes.
I think you're going to have one per CPU per C group.
Yes, so that is something that doesn't convince me too much because the thing is that, okay, we might have a high number of C groups, so we will need to iterate through all of them, and we are in a hotbed, so I don't really like that much. But also the thing is that I'm not sure if here I put those events because that's what made sense to me.
But I don't know if like it makes sense to go and follow those events also for those hierarchical servers, because the simplest way would be, okay, we just don't validate the hierarchical servers in this way because it's just too complicated. But I would hope there is a better way. Well, the thing is that here is the same code that runs all the hierarchical server and the other servers. So we may be fine just validating those. So, well, that's one thing. So, and actually another thing that I wanted to see with you is what else can we validate in the kernel by knowing what we can do right now, also by putting real-time properties. So here, the first example is actually the most stupid that I could think of, but it's good because it's illustrating what we can actually do. It's validating a timer. So it doesn't make sense also because we do use timers under the hood, so you don't validate a timer using timers. But it can show that basically you can start the timer, and then once it's armed, you can stay in the armed state only when, well, before the expiration with some threshold, and you can expire only when the expiration ran out, or you can just stop it without any constraint. So this is very simple, and it's illustrating what we could do. Also, this second example in here is showing that, well, here it's very like on the top of my head, it's not really anything precise or nothing like that, but it's showing how the load balancer could be, well, we can make a model on the load balancer and say that the load balancer, once there is an overload and we do have a target, then we do resolve the overload on time. So by a specific threshold or something like that. Or also here, the third one that I just put, it's like just to show that we could model a row latency. So let's say when we have a need reshed event, then we are rescheduling by some time, by a threshold. If it's reschedule lazy, then the threshold would be higher. But the idea is that we can kind of write a model to say, again, there are other tools for that right now, but you can spot when there is a latency, when you are going to find the latency on the kernel. And those are really just plain models. They are not really maybe too interesting, but I would like to know if there is anything that comes to your mind that you would like to validate inside a subsystem without writing a lot of code inside the subsystem, but to have a model that would be outside, if you have any idea.
I have some question from Prem Corner. Thank you for Nam and Gabriele for the great feature of real-time verification. I've been found that there is some uncompatibility, some pattern in the kernel code. As you know, some IRQ or preemption disabled context, there is some usage after that code. Some of code use the spin lock. As you know, preemptive corner, spin lock goes to sleepover lock. So I found many pattern in something like that code, and I talk about the CVE team, and Greg answered me that bug should be considered as a CVE. Yeah, so I hope that runtime verification would be a good some monitor for that some wrong pattern. And as you know, the config on the debug atomic sleep, they print in the situation when they might reset. So is there some is possible for the some runtime verification that can be monitor the including the some config on the debug atomic sleep features and another some complicated things.
What I don't understand is like what the current situation like with the debug sleep. What is wrong with that?
As you know, when the IRQ or preemption disabled on the real-time kernel,
yes,
they should not sleep.
Yes,
right. But the spin lock goes to a sleepable lock.
Yes, no, what I wanted to ask you is like, okay, there is a debug sleep already that would show you a splat when this thing happens, right?
Yeah.
Why isn't that enough?
So
what is the problem with just using that, and why do you want to have a monitor?
Yeah. If the scheduling is not occurred, debug atomic sleep can hard to print the situation. Yeah. So I think real-time verification should be check that situation that not scheduling really occurred. So yeah.
The question is, there's already mechanisms that do that, that detect that already. So one thing is, there's Alexander Arling. Has he talked to you? He's the one that he's remote. I don't know. He's in Ottawa, so I don't know if it's 10:30 p.m. right now. He was here earlier before the break. I don't know if he's still online. Alexander, are you there? No, maybe not. But he had several use cases that he needed for. Has he talked with you before?
Yes.
Okay, so I know he had some stuff. I don't know if there's anything, but I'm wondering if you should talk to Greg Hartman or anything about USB, because I know the USB protocol has a lot of timing constraints.
Yeah.
And I'm wondering if verifying that the timing constraints are being met might be useful or not, or find out, hey, here's where the bugs are in the kernel. I don't know if you asked him about that, just for that. Have you?
Related, not exactly same as the schedule EVDF. We have taken some liberties with the math, saying these cases should never happen. And being able to verify that they actually don't happen when they actually do. I have tests proving that they do happen. Would be useful.
All right. Just to answer your question before, like everything would be possible. You could instrument the might sleep. There were models or ideas to have that. It might be a heavy thing to instrument every single might sleep. It might not. That depends. Again, you need to understand whether what is already there, that I think it's already attached to the might sleep. Why is that not enough? Because it might really be the exact same thing. You, instead of producing a splat, you just do print K or whatever, but you're still there probably. You're not obtaining more than that. Yes, of course.
Said that so these things have potentially you can implement your own reactor, so the thing that actually does something when the model detects a failure. So it could be like a more general way to attach a different type of reactor to the might sleep track.
Yeah. If you want, instead of just show a splat, you want to do something like correct the situation, whatever. Yeah, that can be a use of the reactors. All right.
I actually just want to make sure I'd like to work to get other people, because right now people think runtime verifier is just like real-time stuff, and it could actually be used, like I said, USB, anything that has complex or complexity with the design, and you want to verify that your code is actually doing it properly. It's basically you create your model, you compile it, put it in, and it will verify runtime. It's very, very low overhead. So this is something that's run in production. So if you want to make sure, he has a presentation at 3 after lunch. Right? Yeah, right after lunch, he has a presentation. I recommend you not people in this room. I think everyone in this room kind of has a good idea, but try to get other people to say, hey, you want to verify your code outside of the real-time schedulers, folks, drivers, device drivers.
Well, actually, we in the in the automotive, we have such a constraints. For example, when the watchdog is one of the main thing that can tells you that you are meeting the constraints, and we may want to verify that the code around the watchdog is executed as it is intended.
Dudex and Daniel was doing this. He explained to me the whole thing about the watchdog and the purpose of it, and it was for safety safety critical systems, automotive. So the whole purpose of this was kind of started by the watchdog timer, because I guess the idea is as long you have to prove the watchdog timer is correct. That's the one thing you have to prove. You can say the Linux isn't correct, it's running there, but the watchdog timers make sure that the Linux kernel doesn't do something stupid. If the watchdog, when it detects it, then it goes into a safety critical mode. And that was acceptable that's what Daniel told me about. So he said, but you had to verify the watchdog, make sure that it wasn't buggy or whatnot. Well,
watchdog itself, because the watchdog itself is driven by hardware. I mean the configuration of the watchdog.
The watchdog, what the watchdog would do, that's it. Anyone else?
Yeah, as I mentioned, thank you for to share those kind of things about USB. Most likely also some other subsystem like networks might need some more state machines or stuff like that. What I really wanted to see as they mentioned about the EVDF, I'm not that familiar with it, but I'm sure it has some timing constraints. So that's why I wanted to show it with you guys from the scheduler, because I'm sure there is something that can
actually
be done there.
EVDF is a little more interesting than timing constraints. The model itself has some mathematical bounds that, if the algorithm works properly, should always be met. But because we do not use the same math, we start approximating that invariant doesn't hold true.
Okay.
So it would be good to know how often how much are we missing it by, and so on.
Yes. Or for instance, that gets a bit more wild, but like the first presentation of today, we were talking about understanding what kind of tasks are having problems with LLC and migrations and stuff like that. We could potentially write one model like this and having access, I don't know how easy it can be done, having access to the PMUs, and in some states, try to understand what is happening in there. So like classifying tasks in that way. So that could be another possibility. All right. Thank you.
Ah, tu les as changés?
Ouais, des trucs à changer. J'ai enfin pu avoir du jeu.
Par contre, de ce que là, on a téléchargé, c'était Valentin. Là, c'est la version de ce matin. Okay. En fait, on les a chargés sur place. Il fallait que tu le dises juste avant.
Ouais, non, mais... All right. Okay, let's go then. Hi, everyone. I'm Valentin Schneider, working for Red Hat, and going to something a bit adjacent to scheduling and real-time. It's going to be CPU isolation and IPI interference. So what do I care about when I'm talking about this? So the context here is CPU isolation with all the bells and whistles. So you really want to isolate one CPU or a range of CPUs and have nothing put on there that you didn't put yourself. So if you have something like DPDK, you have a pure user space application that's going to be like running forever, and you don't want any kernel interference, right? So the scheduler take and any other sort of pesky interruptions. You don't want any of that on that CPU. And like right now, if you do that, like isolate a CPU on an x86 machine and record with ftrace, like what's going on, you will see that eventually, if you have stuff running on the other CPUs, so the housekeeping CPUs, the CPUs that aren't isolated, it's going to generate interference on your isolated CPUs. What I'm seeing is mostly IPIs from so textbook on x86. That's the stuff you go through when you're updating kernel text. That's mainly going to be static keys, right? So I don't have the number. If you go look at the kernel source, you have a lot of static keys being used because they're really handy. But anytime you flip one of these, you're going to IPI all of the CPUs in the system. Again, on x86. On other architectures, it's slightly different, but x86 is funny with textbook. And then you also have TLB flushes. So like my little test case to reproduce this, I just run LT-eval, which is going to run kernel compilation and a hackbench, right? So the housekeeping CPUs are doing all sorts of random stuff, and that's generating TLB flushes, which end up interfering or causing interference on the isolated CPUs. So the little thing I've been working on for a few years now is the idea that if all of this work that's being sent to the isolated CPUs only concerns the kernel space, well, we don't have to interrupt the user space task right away to do it. We can just say, like, okay, remember we have to do this, and the next time we enter the kernel, we're going to execute this operation. So for static keys, it looks obvious. It's like, okay, if I'm updating kernel text, I don't need to interrupt a process that's executing user space code. It's never going to hit this kernel instruction until it enters the kernel, so we can just postpone it to the kernel entry. This is where things get interesting. So it looks nice on paper. There is something we have to be careful with is, yes, we say we're going to execute the third operation as soon as we enter the kernel. And the detail is what is really as soon as we enter the kernel, right? Because you can't immediately arbitrarily or execute somewhat arbitrary code when you enter the kernel. You have, like, if you have KPTI, you have to switch to the kernel page table and set up your stack and do some little things until you can actually execute the deferred operation. So on the left, it's what it looks like from a high point of view when you're sending an API for, I think that's textbook, yeah. So yeah, that's that. You enter the kernel, switch to the kernel page table, goes through the context tracking stuff, and then eventually you execute your callback. And you'll see that you have arrows going both ways, so that's a synchronous operation. Whereas with my deferral approach, it obviously becomes asynchronous because you store the information that you have to execute this the next time you enter the kernel, but then you can have hours that go by before you actually have to enter the kernel for some other reason, and you execute this deferred operation. So really the code down there on the right, that's where you have to be careful that...
So, question.
Yep, go ahead.
Basically, you basically listed the things right there, like IRQ entry from, I mean, there's like TLB flushes, sync cores, which is just basically a memory barrier, full things.
Yep.
There's a small finite set of things that do IPIs, correct?
Yes. I wouldn't say small, but...
I mean, like how many? Like 100 or 10, or I mean...
It's like, it's difficult to say like which ones you're going to encounter generally, because there's a lot that are like driver specific, so it's going to vary a lot with the hardware that you're running. But yeah.
So wait, I'm curious about the reason why I'm saying is if there's like if you could get down to a set of things that are sent to IPIs, if you know an isolated CPU goes into user space, you could, and it's going into user space, it's going to be in user space for a very long time. So entering the kernel or going into user space and coming back from user space, you could say that's going to be a very slow path.
Yeah, I mean, with no hertz,
right?
It already...
Yeah, no hertz, just boom, you're going to go in, and this is way, if you're going to set this, set it up and say, basically take this CPU out of, like, once it gets to a certain point, we do a synchronization point where it's just about to go into user space, and say, take this off of the IPI sending. This will not get any IPIs whatsoever. You're in user space, and when you come out of user space, do everything. You don't, like, basically don't store like, okay, this one to be done, this one to be done, this one to be done. Just do everything. All the synchronization. It's going to be very slow, but you don't care.
So it actually got funny you said that, because I have two different approaches to tackle this. So the nice way that we use is context tracking. So yeah, you see that you actually execute sync or off of context tracking. So for that, that's for text updates, and that works nicely. Thanks to Josh, we have some nice instrumentation to make sure we don't have any problems with the danger zone with accessing static keys or static calls. TLB flushes have been a pain in the ass to like make work for this. And so the suggestion from Dave Hansen was to sort of do that, which is like when you have the switch to the kernel page table, immediately after that, do an unconditional TLB flush.
Yeah.
Because then you know that can't have been accessing like unmapped pages, and that solves the problem for you. The problem is the code for that is absolutely horrendous, and yeah, it makes things slower. But I'm kind of with you on the argument that if you're running nodes full and CPU isolation,
Yes.
you enter the kernel, you lose.
Yes.
Play the game and you lost.
Yep.
So,
That's my. It's a slope. That's the point. Is I don't want to be bothered by the kernel. Well, that's because you're going to be in user space for so long. When you enter the kernel, like, okay, now you have to do everything that you weren't bothered for. I don't think that's. I don't know. I don't think that's a problem. I personally.
So well, it is slightly tricky in that you're in super early entry code, so you don't want to unconditionally execute something that isn't going to affect you. Like for instance, at Red Hat for the rail kernels, we build the kernels with no hurtful enabled, even if it's not being used.
I think it's got to be some sort
That's okay, go ahead. Oh, okay. Yeah, sure.
I just want to say that we need to have some sort of system call or something that say I'm entering this mode, and now so basically it's going to be the user space is going to say I don't want to be bothered by the kernel. So it's not just being ISO CPUs and anything running on it is going to go through all this crap. I think we really do need a way of saying the application saying I don't want to be bothered by the kernel, and then it's going to be totally impacted if it goes into the kernel.
Yeah, that's what we do. We've been doing that for, I don't know, 5 or 7 years now. We just turned that off. And the reason why is as soon as you upset your memory mapping in order to go into the kernel, you've lost everything, right? There's just no way you're going to be able to deal with that. Even simple things like we run soft GPS and it's hard real time. If you miss your tick coming up to update your phase lock loop, you're just done. The whole thing is just going to go sideways for you. So stuff like this, I don't know what the deferral gets you. If you're taking that IPI and you're caching it for later, it's going to be like hours later when somebody exits that program. Is the person who, or is the task that asked you for an IPI going to really care that you're going to execute it now? Doesn't make sense.
Some other item actually in the danger zone, I'm not sure you looked at. It's like I've seen a lot IPIs being used to handle erratas, especially on Armored. I'm not sure, to be honest, the details, but something to consider, like, can they be deferred safely or not in these cases? That potentially can add more to the complexity.
Yeah, I haven't looked too much at the other architectures. Actually, I know that last time I looked at that for ARM64, they don't need any of that, at least for the two ones I mentioned, because for text updates, the architecture actually guarantees that the right thing happens when you patch branch instructions. And they have the TLBI instruction, which means you don't have to send IPIs to do TLB invalidation. So
I think I've seen some erratas like where they require sending to our mate CPU to force a flushing, like the caches and this kind of
thing. Is it like the, I don't know, SunderX sort of ugly erratas or?
Yeah, probably some hardware issues that require.
I'm not okay with saying if you have.
Yeah, but hardware. I mean, just like something, I'm not sure if it is a problem or not, but I just thought I'll highlight it in case something is not in your radar.
Thank you. And I think that sort of summarizes that. Yeah, so an argument against all of this mess that I'm adding for the TLB flush stuff is we are leaning towards having support for that in hardware for x86. So for AMD, there already is the like invalidated broadcast stuff that is supported in, what did I write? Oh, I didn't write on it. I think it's 615. And Intel has RA, I think it's remote action request, which isn't supported yet, but I mean, it's in the works. So yeah, I mean, the super early entry unconditional stuff, I'd invite you to have a look at the code, but I wrote it and I hate it. So it's, yeah, the problem is it's not that clean. And yeah, it's kind of, I would like to have like a clear or a clear indication or a clear message like, yeah, keep hammering at this, or like just wait for new hardware to roll in and then tell the customers, well, spend a few dollars, well, more than a few dollars, but spend some money and, you know, have the problem solved for you.
what would an API look like for that, for take this CPU out of circulation so that I can use it for real time? What should we do? Yeah.
You mean like with the API for, you mean for the application to just say that it wants to be, I mean, well, first of all, you need no hertz full. And then we have ISO CPUs, which, well, we don't use, it's CPU sets, right? That we try to use, or that was one thing. It's like, have we ever got that working?
I think it's not yet complete, but closer and closer.
Yeah.
Yeah.
So,
It is,
okay, yeah. So right now, there's a thing that Peter Zylstra hates is that's on the kernel command line, you can say ISO CPUs and the RC, and like basically you shut these CPUs down. Right now, that's the only thing that works, pretty much guaranteed to work. Yeah. Well, that's the thing. We have CPU sets that are being used to basically, we're trying to get CPU sets to do the exact same thing. I guess it's a work in progress. Is it done? Okay. And but once that's done, then that you would use CPU sets to take it off, and then we probably would need a new type of system call or PR control or something to say, it'd be a system application would actually say, I don't want to be bothered. So because once we don't want, as we were saying, if we do this, always destroy, like make it really expensive. We don't want to do it for any application that happens to be on that CPU, or especially if it's a CPU set. You want to do it where you say, I really don't want to be bothered.
But then the
Here.
Safety critical stuff. It's hard real time stuff. Not media stuff like that, right? And this kind of thing is really needed. So we do that, but we expect it. Nobody wants that kind of code. So, yeah.
Actually, this is very, very popular with the high frequency trading folks. Sure. They are very much care about stuff like this. So it's not just safety critical. It's safety critical if someone loses a trade and you lose $1 billion, so you might be killed, but that's something different.
But yeah, just to go back on the interface of PLCTL, the tricky thing is for like consuming this interface, it has to be like in super early entry assembly code. So you don't get all of the C niceness.
What?
Like because let me try and form a thought here. You want to have unconditional or like a list of operations that you do at early entry code, like for instance, do the TLB first right after switching to the kernel page table, but you don't want that to be purely unconditional. You want that to be gated by, oh, I have been running a process that requested this.
Yeah, so basically on entry to kernel, like in the no instrument time, whatever, like when you enter the kernel, there could be a check of the task struct that has a flag that says, this guy needs to go through a full. So it would be probably in the task, it would have to be on the task struct that you have access to right away. Once you enter, you get this, before you do anything else in the kernel, you just go right into doing this. And that means even on any interrupt, anything.
Yeah, I mean, you just reuse the the entry code. Yeah. Yeah, okay. Yeah, and I think that was from Frederick's suggestion. I have a little bit of assembly code to have static keys usable there. So with the PLCTL, we could just enable the static key at the first user. And so then if you have a kernel compile with no hertzful, but you're not using that, then
can a static key live in a no instrument?
Yes.
Oh, it can. Okay. Wasn't sure if that was.
But actually, yeah, if you update it at runtime, that's another. Because I think I did that only considering it was updated at init, not at runtime. I'll get back to this.
Yeah.
There's a question.
Yeah, so thanks for bringing this up. I guess I'm not sure if there's much discussion, but like apart from just interrupts, there are certain things that can also hurt you quite a bit. So if you're trying to mix a lot of general purpose tasks, reading logs and whatnot, you end up at a point where, like, for example, you have the free per CPU pages. And if you have an isolated core just sitting there that never hits the kernel and never gives up its slice, then eventually you would lock up the system. So I think if we're going to go for like an API, I suppose that API should also cover multiple cases. Like, hey, I do this PICTL, flush all of my pages, give everything back, make sure that, if I stay on this forever, I don't just get interrupted And I also don't have to worry about not giving up my slides and blocking up everything else.
Yeah, no, for I don't remember for which subsystem it was, but for some of the per CPU allocation, I know that some people have been doing like kind of ad hoc solutions where they can pretty much do that when they see that they're running on a no-hurtful kernel with no-hurtful application. But that's like a per system or per subsystem basis. It's not like, yeah, a generic solution.
One real quick, he just brought up something I was talking to, I think Clark Williams about this before, that especially if you have a large machine, people don't realize that CPU usage isn't the only thing, or in IPI. So if you're running a task, you could lock up the bus by other CPUs. Other CPUs could do things that could lock up the memory bus. And you could, suddenly your system could just, so your CPU could stop without doing it. And I don't know if we have ways to detect that or not, of VMUs or not, but just be aware. I don't know if people are aware of this. If you have a large machine, things on other CPUs can highly affect another application running on another CPU. They just have to be aware. So ISO CPUs you may be wondering, why is my machine or my task running slow, and not realize that the CPU bus is locked up.
But yeah, that's also part of like your system design. Like if you have NUMA and try and nicely just use one node with all of the bus.
I have a potentially stupid question, but doesn't switching the kernel CR3 already do a TLB flush?
So I'm not a memory management expert, but as far as I can tell, not in all the cases. Like I don't remember which option. It's like global pages stuff. You need a CS.
But if you're using KPTI, you're already disabling the global bit. So
yeah. Okay.
I don't know, something to think about.
Yeah. Thank you. And yeah, that's all I had. So.
Yes, thank you.
Thank you.
Just, yeah, is it yours?
Hello everyone, I'm Shrikant Hegde. I work at Linux Technology Center at IBM. I have Ilya here with me. So we're going to talk about per-hour scheduling, a framework for better CPU usage. So this is a follow-up to what we started last year. So we'll get started on the problem statement, whatnots, and implementation details. We have a lot of questions. We want the feedback from you guys here. Okay, we'll quickly go through the problem statement. So it's a virtualized environment where you have a lot of virtual machines. That means, okay, when we say vCPU, it's a virtual CPU that's running inside a VM. And there are physical CPU, we call it as pCPU, which is managed by the host. So the usual scenario is you have overcommits. That means more vCPUs than the physical CPUs. That's okay because most of the time, we don't expect all the VMs to be active at the same time. So that's what indicated by the first two diagrams here. And but the problem is when all the VMs do become active at the same time, then the number of vCPU requests cannot be met by the host. So host has to do vCPU preemption. It could be to preempt another VM, or it could be preempt another vCPU within the same VM, both of which could potentially hurt. And we see this problem with enterprise workloads, tanking the throughput, as well as with micro benchmarks when there are a lot of vCPU preemption. That's what indicated by the third diagram here. So what we want to achieve is indicated by the fourth diagram, that what we want to do is a cooperative per-hour scheduling where we want to restrict the workload to limited set of CPUs instead of consuming all the CPUs. Okay. So when I say limit the workload to limited set of CPUs, first thing that might come to mind is explicit affinity. Why don't you do a task set the workload to set of CPUs? But that's a difficult task for a user. Then we thought of exploring CPU hot plug, but it was quite slow. And since it does involve SCAD domain rebuild, and there are synchronized RCO stuff there, so which makes it slow. There are some works in progress. Hopefully some patches should be sent around those lines. And then one thing that Pratik suggested some time back, thanks to Pratik, on that isolated CPU set creation. Why don't you create on the fly the isolated CPU sets? That works faster compared to CPU hot plug, but still involves SCAD domain rebuild. Then what I realized when working on that isolated CPU set is we are going to break the user affinities. So what I mean by that is when the last CPU in the user mask goes offline, we are going to reset the mask. That's the current design. That's okay for hot plug or the CPU set current use case because the changes are driven by the user. So user is aware of what's going on. Whereas in the current case, it's driven by the system. User is not driving it, so we can't break the user affinities. Yes.
Heard something about synchronized RCU. Is it, will expedited grace periods help out?
Yeah,
Order of
exactly.
magnitude
So
faster
we
than the
tried that.
Yeah.
I think we tried synchronized RCU expedited. That brings down the time significantly. But the point is still that hot plug as well as CPU isolate will break the user space affinities.
So it helps, but doesn't solve entirely. Is it also a problem where it's having side effects where the expediting is happening when you don't want it to? And consuming extra CPU, or is that not a problem?
Yeah, I think when we do that said expedited, it brings down time by 95%-ish, something like that. But I was wondering, because we are sending IPIs to each CPU to do that expedited thing, does it have any side effects? We are evaluating that.
Well, what I'm wondering is if it would be worthwhile in your case to say, all right, we're doing this hot plug operation, so let's make all the grace periods expedited.
Okay.
Do it and then turn that off.
Okay.
Maybe you send me an email or something. We can.
Yeah. It could be done. Like currently, the PowerPC has SMT8, so it makes the situation aggravated. But we could do something either in the kernel space or in the user space who is driving the SMT to do this expedited thing.
Anyway, if 95% isn't what you need, then you need something else anyway.
Yeah, sure. Yeah, and that even if you get the hot plug and other thing, I think that still the user space breaking is the reason why we need a new interface. And the last, not but the least, was capacity aware scheduling, which we were exploring last year, setting like extreme values, 1 versus 1024. That didn't work out well with all the hacks that I had. It didn't push the task out completely under even a high load when I have a lot of threads run equal to number of CPUs. So what we need is a lightweight framework which should help to move the task away from certain CPU at this point. I'm going to call these certain CPUs as paravert CPUs. Bear with me till we find a better name. That's in discussion in the upstream. We haven't found a better name yet. And then we shouldn't break the user space affinities. Any questions or concern at this point? Voice.
Understand because the context is virtualized CPUs. When you say user space, user specified affinities, do you mean somebody specifying the vCPU affinity or
vCPU affinity? You could be setting vCPU affinities.
But here it's not the user, here is the admin, really, not the actual user. Or do you mean the customer who's
user means the one who is like running, like say I'm running StressNG with I can do a task set and within the VM.
Okay, so like you're talking about the virtualized inside the VM.
Yeah, I can run. For example, I'll say when I spawn multiple VMs in the KVM, I can specify StressNG with task set, right? I can when I do that command, then the vCPU runs in the host. That's a later stage. But I do have the user affinities. But what happens during hot plug is when the last CPU goes offline. In that, let's say I specified a user affinity mask. Let's say CPU 0 and 1.
For the vCPUs.
Yeah, vCPUs, yes. Right? So what happens when you do offline, that is still happening in the guest. I'm still in the guest VM. I haven't.
Okay, so basically static partitioning the VMs, and that's what's being broken. Okay.
Hey, I have a question.
Am I right in this one? Matthew? Okay, Saravana. Okay, go ahead.
Hey, Saravana here, online. I'm not sure if you're going to talk about this more and if this is what you mean by capacity aware scheduling,
but are you trying to introduce some form of like something similar to thermal pressure into the
It was like explicitly setting capacity to like 1 versus 1024. We have currently 1024 as a default CPU capacity. That way, yeah. Indirectly,
You're basically saying
if
like
that
completely
solution
take
was to work,
everything off
it
for the
has to
kind
come
of
through hardware pressure.
Sorry, we spoke over each other. Can you repeat the last part?
Can you come again?
Can you repeat your part? I think we spoke over each other.
What is this?
Sorry, can you repeat yourself?
Something is being isn't. Okay, we are preempted by something now. Can you speak?
Can you hear me, or is it really bad audio?
Yeah, we can hear
The
you.
volume
In the room, I think the projection has gone off. So
Okay. Yeah, I turned off the video. I was just asking you to repeat your last point because I missed it. That's all.
okay. So what I mean by capacity aware scheduling is explicitly setting capacity, CPU capacity to like two extreme values, like 1 versus 1024. So by default is 1024. Let's say if I set it to 1, does the current mechanism take care and move the task away completely from the CPU? That doesn't work as of today.
Oh, it doesn't work? Okay. Cool.
Sorry, go ahead, Sarona.
That's all, Vasan. Go ahead.
Yeah, for the capacity, it's just that, and we can't set the capacity to 0 because of all the division that we have. That's what.
That's why I set it to 1.
Yeah.
Yeah, but problem I think that is currently it caters to a lot of use cases with async packing and big little. We try to bump it up to highest value. That group overloaded above that. Still there were. After that, when you have high concurrency, it comes down to math. I think that's where things become equal and we don't move the task out. Okay. Should I proceed further or should we wait? I don't think we can proceed further. Can go to the next slide and we'll wait for some time.
If you're waiting for me, I'm done. Please go ahead.
But yeah.
So should we wait or?
No, you can.
Okay. Yeah. Okay. Okay. So you might have to imagine what I'm speaking. Sorry. So there are currently two approaches that in the beginning of the year we started with Tobias had sent out a series to use the load balancing method, where we are going to define a new load balancing type called as group parked, which was at a higher priority compared to group overloaded. So it will work in the cases where most of the cases it worked, but it was a bit slow. I think that's one of the agreement that we have, that load balancer can be slow on large systems especially. So that's when we are wondering, why don't we do something similar to hot plug, but take away the overheads of hot plug we are currently dealing with, and don't break the affinities. So why don't we just, okay, it's back. I'm talking about, I just spoke about the first part. I'm speaking about the second on the right side, the approach. That's the current preferred approach as of today. And so we do things like similar to hot plug. We push the task out when certain CPUs as marked as para-out, and we see it is quite fast and it works pretty well in most of the cases without no splat or lockup. Okay. Coming into the implementation details, we are going to define a new CPU mask called a CPU para-out mask, which is going to contain list of CPUs which are not supposed to be used at this point. And we'll make load balancer as well as wake up aware of it, so no new task ends up on those para-out CPUs. And we push out currently for FAIR and RT. It's mostly for FAIR 99% of the time, but 1% of the time you might have RT tasks, so I didn't want to take a chance there. So right now it works for both. Yeah, and these are the generic bits, the scheduler bits in the top paragraph. Then comes the architecture specific bits, like how each architecture is going to set this mask. that right now in PowerPC, it's a very simple implementation where we query VM level details such as entitlements. We calculate the steal values over interval of time. And based on that, we calculate the number of cores to use and set the mask accordingly. I'll hand it over to Ilya to speak about S390 and performance numbers.
Thank you, Shrikant. So I work in Linux and S390, so IBM Z area, and overcommit is currently a big topic for us because our users love doing that. Also, we have this hypervisor called Prism, which is proprietary non-KVM, which likes to take CPUs away for a really long time, think seconds, and we don't really want to put work on them. So we actually have a intermediate solution today called HyperDispatch that's already upstream. That's an S390 kernel feature, which tries to predict that this is about to happen based on steal time and also hints from the hypervisor. And then it uses capacity-aware scheduling to attempt to put less work on the affected CPUs. And while the host is overloaded and guest not, it works fine. It actually does bring benefits. When both guest and host are overloaded, then capacity-aware scheduling, as we just discussed, doesn't really help. So we're looking forward to using something like CPU pervert mask in HyperDispatch. But also we think that this may help generic KVM use case. For example, if we have 3 vCPUs, but the host can give us CPU time only for 2, then it's better to trade vCPU preemption for in-guest preemption by just saying, okay, we don't schedule anything on one of the CPUs. And so this is a proof of concept I made. Therefore, I ported the heuristic from HyperDispatch to common code, of course, excluding S390 specific bits. And then we ran some evaluations by running benchmarks in multiple VMs under overcommit conditions, of course. And then we compared latencies and aggregate, so not in a single VM, but aggregate throughput numbers. And we did this for 3 architectures, PowerPC, S390, and also Intel. So DayTrader, this is a complicated benchmark which simulates stock trading. And we ran one VM with DayTrader and the other VM with StressNG. And this patch provides, or series provides, quite a noticeable speed up. And then, of course, if we also look at Hackbench and SCHbench, more popular benchmarks, there are also very noticeable wins, both in terms of latencies and throughputs. So these are the figures on 390. Here we varied system configurations a little bit, so different numbers of VMs and vCPUs. And here we could also see very good wins on Hackbench. The rest were actually supposed to be more or less neutral. We see some regressions that we are still debugging. But they are not something, at least we believe, inherent to the design of the patch series. And unsurprisingly, on Intel, the picture is roughly the same because this is the common code proof of concept patch. And with this, I give it back to you, Shrikant.
Thanks, Ilya. I think these questions are not in any order except the first question, that is this the right approach or is there anything better that we can do? I'm looking for feedback from all of you guys, and feel free to say if this is not right. Okay, if not right away, you can suggest over the mailing list. That's fine too. I think the second one is the naming thing. I think we cannot conclude it right away. I have some names, like I think if you see the infra per se, it's more of avoid framework, like we are avoiding certain vCPUs at this point in time. But we probably need a better name. I think maybe contended, like mask, maybe contended name or something of that sort. Another couple of, I think, important ones that I wanted feedback was on the last 3. That is, one is, are there any user space daemon apart from IRQ balance which should be aware of this mask? IRQ balance has to be aware of this mask because it should not send the IRQs to those CPUs which are marked as paravert at this point. But is there anything else that we need to be aware? Okay.
So some of the user space threading framework might benefit from knowing that these CPUs are unavailable. Else, if they say that, okay, I want to pin a worker here based on.
Yeah, brilliant point. I think SCH bench does that because we initially saw a huge regression with SCH bench.
So yeah, some of it's auto mode that Chris recently added that
Yeah.
would set the L3 masks and set affinities. That may
But
benefit.
they have this locking thing in SCH bench where they pin the workload to
Yes,
specific
that too.
CPU. That when I use without that -L option, it works. There are no regressions with that. Yeah, that's something. Yeah, okay, I'll think about that. Yeah, other one is the architecture.
Yeah, is there some overlap with vCPU is preempted?
vCPU preempted to certain extent, yes, but that doesn't enforce any policy as of today. It's more like at the wake up, we see if vCPU is preempted, we don't try to place the task there.
Well, I think it's used right now for spin locks.
Yeah, same is true. But if you're running, it's not you will not be vacating the CPU.
Right, but you could be using the same like underlying.
Yeah, most of the time, like if your workload is very short running, like it does a lot of wake ups, that's probably works, but not in all cases. Okay, so one feedback that I want is how to do the policy here, especially the arc specific. There will be arc specific bits, and that has to be fed into the generic infra. For example, in S390, I think we have this vertical high, vertical low, vertical medium concept, where this is coming from the hypervisor hardware itself. So that has to feed into the scheduler bits. And then in Power VM also, we are exploring about providing a explicit hint, hardware hint to the each VMs, and to say go and use these vCPUs only. So that's also in works. So the reason I'm bringing it up is because I think last Paravert, that KVM vCPU boosted thing that was going on, we ended up taking an approach where it went to I think BPF, if I'm not wrong, but Power VM kind of thing may not understand BPF. That's the rationale I'm coming from. So it has to be. I think we can do something similar to what currently vCPU preempted does. It's an arc. There's an arc hooks and arc specific implementation and does it in your own way. And then other one is the generic still time based policy. So what I mean by that is currently what we are doing in Power VM, like we calculate the still time over a regular period and make a decision. That can be a generic stuff because still time as a concept is there in all architectures. Yeah, I think those are the main discussion points that I had. Apart from like, other one is is there any questions or anything?
Shrikant, I had a question, if you can hear me.
Can you
Unless you can
speak
hear
again?
me, I'll go ahead and ask my question. You said the capacity stuff didn't work. So in this parking case, are you saying anytime the vCPU gets context switched out, you're going to try to put the CPU in park mode, or how are you avoiding, like how would you identify which CPU to park and when to unpark?
Yeah, right now, yeah, it's a tricky thing to solve. Right now, currently the simpler implementation that we have in PowerPC, we try to take out the last set of cores based on the still time, but that should be spliced across the NUMA nodes if you have multiple NUMA nodes. Yeah, but I think on S390 it's a bit easier because we have this hardware hints, vertical high, vertical low, and maybe we can just take out the vertical low CPUs depending on the still time.
Yeah,
Sorry, I don't know
that's what we do today already with high dispatch.
Is that answer your question? Or,
Yeah, I was saying I didn't know what vertical high, vertical low means, but it kind of answers my question. My other part was going to be if two virtual CPUs are getting like multiplex, let's say 50% duty cycle, between two different VMs, wouldn't it be better to use them at 50% capacity instead of trying to park it away?
I think if you zoom out, that's what we will try to do with this. If you see from MPStat kind of an infra, it will be similar to that.
Okay. Yeah, then I still didn't get like when you park and unpark, but I think we're running out of time maybe. I don't know.
Sorry, I didn't get the question.
It's still not clear to me how you handle the duty cycle, 50% duty cycle in case. Like based on, it depends on how you're going to park and unpark, and I still don't understand how that's going to work.
Okay. Let's say, let's say simpler implementation, we find the steal time to be like, let's say higher than certain threshold, like say 10%. That's tunable one. In that case, we will do in a stepwise approach. We just first take the one core out. So there will be less steal time the next time onwards. And then if there's still higher steal time, reduce it further, and try to avoid the ping pongs, just on the oscillations. So that way we will do a stepwise approach and reduce the number of cores being used at the same, like at a point in time.
Okay. Thank you.
Okay. I think the other one is how much time we have? Okay, we have time. The other one is,
Maybe a quick comment about that. So, sorry.
I was not clear on how you say something about how you preempt the running thread. You say you run a stopper thread on the next tick. But if the vCPU is preempted, nothing will run on any ticks in the future until the vCPU is not preempted anymore. So, or do you mean that when the vCPU finally wakes up at some distant time in the future, then you will preempt the thread from it?
Yeah.
Because you feel that this vCPU is likely to get preempted again.
Okay. You will have the tick as long as you have a task running. And you will have the tick when, let's say, wake up. Let's say user has, for example, we are not breaking user space affinity here, right? So let's say user has pinned only to a parawatt CPU or CPU which is in the parawatt mask, then tick is still running there, but it can't push the task out anyway. So that way we are not breaking the affinities. So a tick will stop running when it goes really idle, like no hot CPUs and there are no tasks pending there. Otherwise, tick will continue to run and will try to push the task out. This is exactly what we do in Hotplug today.
So maybe from the S390 perspective, we plan or already today rely on being able to predict that this is going to happen. So if the hypervisor now takes the CPU away from us for 2 seconds, we've already lost. However, we on S390 get an interrupt a few microseconds before telling us that this is about to happen, and we have to react in this time window to make it really work. And yeah.
That's all we had. Thank you.
Hey, is my audio actually better now? Sorry.
Yeah.
Sorry, Vasant, go ahead.
You. I don't understand what you're saying, Sarah. So that was the last talk for the scheduler and real-time macrocomps. Thank you, everybody, to join us. And so I just want to mention that in April, we'll have the OSPM conference. It will be in UK, I think, Cambridge. So the goal is to discuss about scheduling as well and power management. I think the open for proposal will open early next year. So yeah, if you want to continue any discussion, don't hesitate to make a proposal. Thank you, everybody.
I'm glad that someone likes. I know. I think I'll business people either way, but anyway, what's there said at least. So, in the end, as free time, not but as much. Before the meeting, I want to get very interested.
Oh, I see.
Thank you.
I expected. For migration.
Four of them have three each. And the youngest looks at one of them and says, no. Exactly. The girls have three each, and Sebastian, the oldest son, has three too. Yeah, that's fun. Yeah, especially if all of them get together. You guys forest away, it's an hour from my house. No. So where it is in the village, Puerto lives 10 minutes away. My oldest son, an hour, and the daughter, she's an hour away. So it's close together. Occasionally, everybody assembles at some place. I should go out after 2 hours because he's 17, 18, 19, 22. Yeah, that's 10 plus, no, 10 plus 2 is 12, then adults, and then 12 grandkids. Oh, just get those houses. Yeah. Yeah. So, 24. Yeah. No, he's not married. He has a spouse. Girlfriend. Yeah. So it's everybody comes together. It's big. And then the kids are. So the one is what color is was so, but then there's a gap. Yeah, it was 60. And then there's a gap. And then the other 11 or between 0 and 12 and 7. Okay. And they all together in the room. Yes. And exhausting. Yeah.
Okay. But maybe paper. It's not for the challenging exam. The second, they were a right homework. The second question was about the station. So I tried cooking. Some of them had a so instead of writing this one, I wrote it and I can answer you using the same. Just in case I excuse they ask a reputation. how I deal with the high control. But the answer is so. Okay. Was good. But I didn't put any salt. Yeah. Yeah. By the way, regarding that net thing, even though it's not charging, I'm just saying that. Even if you don't have to charge, I will just adjust. Some machines, some machines. Because only those machines like that, which causes those changes to be expected. Otherwise, which will even if you're just putting assets, then the entire transmission change. Yeah, some machines, like I get one machine and then into the future. Another machine. Also do that. So that the volume of the transfusion is big. Hey, but yeah, I agree. You wouldn't be able to see just that. You have to do some volume based on the actions. Take the machines on the axis. Constant pressing. Stick machines. You have to this particular policy. Yeah. Good. How's it going? Adapting to the council change. Next slide. I'm interested in the best option. Recommended like taking a train to 20 hours, I think. Yeah, I have to see if that makes sense for one day. Just, I mean, like you get up in the morning.
Good for you. That's where I know I have to do reviews. One of the first ones on the like the first in, first out is the yeah. Exactly. I have to. What's the how many times with the status of that? Should I wait or is this? Yeah, wait like 60 or maybe after. So. Yeah. And yeah, it's not difficult. I just that any time probably like try to reference some of this. I think most questions were actually more about the kind of economy and stuff. I think I figured out the how it's basically should follow what's in CA is like a common I think that's yeah, but if we want to do that, because I think we could do that, we could say, right, so I decided just to keep it as the same way as if we were using CA. Makes sense. So, yeah, I'm not about this either. You have to whatever you can have. It makes easier to. No, I mean, so you don't like this Japanese food, that's why I think Swiss might. Yeah.
Hi, yes, nice to see you. Thank you so much. Right. Family behind. Like, why don't you know it? It has a bunch of. Roughly how it structures, like how many engineers, how many sales and support. No idea. Because I mean, 180 engineers is probably a lot of key. And they used to have way more. With India, then they like fired like half of India probably. From the office 2 months
Maybe 1 hour 20 minutes is okay for me. That's not too bad, but we do like 80 minutes. Every 2 weeks, I can do it by tomorrow. Every 2 weeks, we can do it like 1 hour. Visit the Reddit office. The Reddit office. See your friends. Yeah, exactly. The Reddit office is like maybe 2 kilometers away from the like part of the city. Yeah. You have to take time.
Click on this as well.
Last year. I heard you destroying our. Yeah, so like the notice period. Oh, and then 300. I used to live long experience from the company for them. Usually it would be 1 month because for some people they that's like whatever applies to the employer. Oh yeah, 1 month easier, so they can get you home. And then my wife co-created it, she's like a assistant to a lawyer. Oh my god. Oh, it's actually before I signed it. Old contract. And then actually could have done it. I guess let's say okay. Thanks. I can write on like. They're going to be there.
You're not going to be in Cambridge. Oh, right.
Doesn't work, you might have to make yourself a center of the picture on the glass.
But okay, I no, yeah, it's a bit, but yeah. It's not CSI. If it is CSI, you can. So how, first of all, then I think that depends. No sure about that because I think yes, hardware. But, yeah. And you can do that for IO. But hypervisor. IO. That's not. That's a depends. Can override the V. You're right. So, hypervisor. I just I need to switch Alice. I have a right. What is cash? I want yeah, but I do not have also. I have many bar maps. I have it. I have memory. From the you can allocate memory. You can allocate memory. Sure, sure. I will not get it. And is that's hypervisor? Hypervisor should have over anyway. Our matter. I want to override. I'm hearing. I've seen. Because I asked for your very like the but it is cacheable. Actually, cacheable address. Right. I think that part of it is yeah, right. And that's why, like, it's fine. I think now I'm getting more your point. We need depending on the architecture. How can you now guys have the different area? There's no restriction about the memory. Recorded driver. We have them. Are you gonna take care? Yeah.
No, we only get one this year.
Only
Yeah. I think in the middle is probably. The other talks. Sorry, Harry. Good to meet you. We have questions. Oh, yes, of course. Yeah. So I can go for no, it's okay. Yes, the last. The only people can ask you. It's probably like 15. So schedule. I update the time.
Hi, everyone. All right. We've got a packed schedule today. We've got, 11 talks to get through. These are discussion topics. Each presenter gets 5 minutes to give their presentation and get everyone up to speed. And then we spend 10 minutes arguing about that presentation. This is going to be a very dynamic session. We've done it before. It worked out pretty well. David and I will be standing around with catch boxes and extra microphones and so on, so we can have a good conversation that everyone should be able to follow, even the people who are online or the people who are watching it later. If you can't get a mic, then hopefully whoever you're talking to will repeat your question or argument point of view. Dave and I will also be monitoring the BBB chat and trying to reflect everything that people are saying offline. So this is going to move fast. And Søren, you're up first, please.
Let's see if I can figure out this part. Presenter. Okay, it works. Hi, everyone. My name is Søren Bagdasaryan. I work at Google, and I would like to discuss today some of the features I'm planning to add to memory allocation profiling. So memory allocation profiling, I'll have to rush through it. So if you have more questions, we can talk afterwards. But it's basically a way to it's a way to report all the allocations in the kernel. This is already upstream feature which can be enabled by a config option. And some of the new features I'm contemplating to add is context capture, memcg support, NUMA awareness, some ioctl APIs, and user space tooling. So context capture, the first one, we already have a POC for that, which is we are experimenting in the Google Fleet. And Saurav, my colleague from the servers world, will present a little bit more about this. But very quickly, what it means is we can select specific allocations and say that we are interested in more context from that allocation. So whenever allocation happens, we can capture call stack, who was allocating, timestamps, and some additional information. So as I said, this is this feature is already implemented. The implementation is pretty simple. We're using tracepoint as Stephen Rosted suggested originally when I was trying to upstream this. And basically having a trace point, a conditional trace point, which is conditioned on user selecting specific allocation, allows us to capture all that information through the BPF or through the event buffers. And in here, I'll let Saurav talk about this deployment in Google Fleet.
Thank you, Suren. So to capture the allocation traces, we load this BPF program that you see on the left-hand side. It extracts the kernel stack ID and PID from the context capture trace points, and it creates a unique key out of that. And we use that key to aggregate the allocated bytes and then store it in a hash map. Now, the data that you see on the right side, or the plot you see on the right side, is the flame graph that you get out of this BPF program. The width for each and every frame that corresponds to the allocated bytes for that function. And at the very bottom, you also get the PID breakdown for the associated allocation. Now, since we only enable context capture for PT-alloc1 in this very case, we only see its callers and callees, and we don't face the overhead for every other allocation that happens in the system, like you would have with trace page alloc. So what is the profiling overhead for an approach like this? Let's start off with the baseline where context capture is not even compiled into the kernel. The very first bar represents the CPU time, which is spent in PT-alloc1. The second bar corresponds to the static overhead. That's where we compile the feature in, but leave the context capture feature disabled for the call site, but the feature is compiled in the kernel. And we see there's about a 21% increase in overhead for that. The third bar corresponds to the active overhead. That's where we enable context capture explicitly for the call site, PT-alloc1, and we face a 64% overhead. And lastly, when we attach the BPF profiler that I showed in the previous slide, that makes it about double. I'll explain why that happens in the next slide. The last two bars show that if you have an alternative allocation function, such as mmalloc, the overhead on PT-alloc is unaffected. Basically, what you have is isolation. So why is the overhead about 2x when you enable this BPF profiler and start capturing the stack IDs and PIDs? In these graphs against the frames, the width doesn't correspond to the allocated bytes anymore, as I showed previously, but rather the number of cycles. And what we see is that 80% of the cycles, they're actually spent getting the stack traces. Less than 8% of the cycles are spent doing the hash table operations. So if you do something intelligent with the stack IDs, do some sort of sampling, this value or this overhead would tremendously go down. So now let's talk about how we've used context capture in the past in the Google Fleet. For some of the machines, what we saw is that the number of IMMU pages were very, very high. And they actually persisted across a VM boot cycle. So you start a VM, stop a VM, and then still the IMMU pages would be very, very high. So then we enabled memory allocation profiling. We saw that PFN to DMAPT, it actually grows over time. Then we enabled context capture for that specific function, and we saw that it comes from the scatter-gather setup of the ATA driver. Now, for the ATA setup, you have an ATA clean, and those in turn call Intel map and Intel unmap functions. And luckily, you have trace points over there. And on getting the Intel IMMU trace points, we actually saw that the size cancel out. So what this means is that you don't really have to debug the driver logic, but rather only focus on the bottom right frames and figure out why those pages aren't being freed. Now, since this is all done through tracing, you can do it in production, and that is what context capture enables in our case. So,
one question from my side. You mentioned that you enabled that through a new IO control, right? That like you for selective allocations. What's the reason for that?
You mean the API, how we enable the context capture, or?
Right. I think like on one of the first slides, you said like you need a new IO control to enable that on selective functions. Couldn't that be done with tracing more elegantly?
Actually, my POC works the way that I write which trace point I want, which allocation I'm interested in into the alloc info, but that sounds pretty crude. So I thought that ioctl would be a nicer interface. Plus, with ioctl, we can also implement some additional features, which I'll talk a bit later. But we can implement like filtering of the data, sorting, and stuff like that. So similar to proc-pit maps, where we have also ioctl to, instead of dump all the information, we just focus on specific subset of that data. So, but yeah, context capture, I'm also planning to have ioctl to enable, to select which allocation we want to capture the context or not. Yeah. Okay, so next feature is MemCG support. And we had a real problem in the Google Fleet where we knew exactly where to look, which MCG we wanted to profile. So with that limitation, it was pretty easy to implement. And that's what this option 1 describes. Basically, what we do is we attach additional condition to allocations to say profile only if this allocation comes from a process that belongs to a C group. So, and implementation is very simple, very straightforward. It's just additional condition. We also have a static key there to prevent additional, that condition to actually affect cases when we don't want to profile C groups. But the limitations of this approach is that we can profile only one C group, and when that C group profiling is enabled, then global profiling is disabled because we are basically using the same infrastructure. So as I said, pros is simplicity, no real overhead, just one additional condition, and the cons are it's pretty limited. It's limited to one group, and it also does not allow you to profile C group plus the global. Do the global profiling. So the option 2 is more complex. We could implement it as a more full-featured thing that we select which C groups we want to profile. So you could say, okay, now I want to start profiling this C group, and so that way we can profile multiple C groups and not lose the global one. But the implementation obviously is much more complex. And I'm just not sure if it's worth it, and if there are many cases where we would need more than one C group profiling. Again, if there is a need, then we have to do it. But I would prefer to stick with the simple option. And again, after this talk, we can discuss if there are some need for this. I just don't have too much time to stop right now.
Is there a way to kind of differentiate MemCG allocation and non-MemCG allocation? The allocations which get charged and those allocations which will not get charged. Mainly, I think that one of the use case is to find such allocations which are not getting charged and they are increasing this system overhead.
So with option 2, yes, because with option 2, we can profile both C group and the global ones. With option 1, where we are basically using the same mechanism, same infrastructure, it won't be possible.
Okay.
Additional things to consider here is that option 2 will have additional overhead both from memory point of view, because for every C group that we want to profile, we have to create the table of code tags again, counters basically, and also whenever we profile, now we are updating two counters, so performance overhead is doubled basically, versus option 1 where we pretty much don't have any additional overhead. So that's the memory C group options. Again, I would love to listen from the input from the community on which option would be preferable here. So next feature is NUMA awareness, which was proposed several months ago. In here, again, there's additional overhead. It is a configuration that can be configured, so we can compile it out. But when it's compiled in, then there is additional overhead, which is scaling linearly with the number of nodes. And the output formats, we probably would want to use ioctl rather than affecting the current output of the file. The main question here is it really actionable? Is it really useful, the data per NUMA memory profiling or not? If it's useful, then I'll prioritize this option. If not, then maybe we don't do it. So the last two features are kind of connected to each other. It's ioctl API, and why I want to introduce it is several things. One is enabling, disabling context capture for specific allocations, filtering by size, by type, let's say page allocations versus slab allocations, or per CPU allocations. We can have also additional extra data to report, like GFP flags when we were allocating. Per NUMA information, again, can be reported through the ioctls. And overall, I heard a number of complaints that the output of the file is pretty big. And if we know exactly what we want, we don't want to read the whole file every time and filter out only the relevant information. So ioctl would be a nice way to address those concerns. And kind of connected to that is a user space tooling. We already have in the AOSP Android open source project, we have a looktop tool, which has some basic functionality like sorting, filtering the data. What we want to add it is, if we go with ioctl commands, and support for ioctl commands, so that user can use command line tool to issue them. And another thing I want to introduce is a categories. So the tool will be configurable where you can say this specific allocations belong to this specific category, let's say network or drivers or MM. So that way you can have a high-level view of the memory usage, and then when you see some regression, you can go and dig into each category. So we're out of time.
Yes. 14 minutes past. You got 1 minute.
Okay. So those are the features I'm contemplating. I would love to get some input. Again, we can do it afterwards, after the presentation. But what I need basically is input on which features seem interesting and useful, so that I can prioritize them first before jumping to other things.
One quick question about the memcg stuff. You can enable or disable this selectively at runtime, right? That you could say like only like do memcg or do it globally, right?
Right. You can do it dynamically, but remember that if you changed it, then you have to kind of capture the snapshot and use it as a baseline, new baseline, because obviously when you profile something and then you switch to profiling some other thing, then you cannot, it's not absolute numbers anymore. You have to kind of reset your base and then look at the deltas.
Right. I just have the gut feeling that like going for an approach where you only have a single set of counters might be easier than two
Oh yeah,
counters.
it's much easier. That's why I want to implement that instead of introduce a lot of complexity and overhead also.
Okay, we're
okay. So
getting to tea time now. So, Craig, you're next. Thank you, Saran.
Okay. Thank you, guys.
I got it. They got to update the slides.
So next up is mem policy, and I'll activate the slides real quick.
Thank you much. All right. Good take presenter, right? Cool. Yeah, talk here is mem policy is dead, long live memory policy. Slightly different. So the story here is actually relatively simple. Past couple of years, I've talked to a lot of device developers, and specifically memory device developers, and they have some kind of special memory that they want to provide to the system. And I apologize for the error on the slide, but they have special memory and I don't want to use it like a file. I just want to use malloc or I want to use mmap. And the prevailing wisdom from kernel has been don't put that in the page allocator for a whole bunch of reasons. Many good reasons, many good kernel devs, not being facetious. But the corollary that comes with that is if you want a service that is in MM, you have to re-implement that service, even just basic allocation and free, right? So what do we do instead right now? We kind of have three different mechanisms. We have DAX devices, we have HMM and zone device, and we have the thing that everyone does anyway, which is they just put it in the page allocator anyway, because they can just do that via EFI or UEFI settings. And DAX is kind of like the X-shaped device goes in the DAX-shaped hole and everyone throws it into DAX, and that's not a good solution either. So I've started to really think about this problem. How do we, what is it? Yeah, I have a couple use cases here, but like, how do we take these use cases like GPU memory, compressed memory devices, and maybe slow memory or big memory pools, for example, and how do we manage these not necessarily in the page allocator, but with the page allocator or with the core services? And all of these different use cases, for example, have different memory policies associated with them. GPUs don't want their memory used as general system RAM, but they do want basic allocation. Compressed memory devices may want really hard controls over what can write to the device, but once the data is there, it maybe doesn't care as long as it gets a write, maybe it gets a page fault on write, for example, and that memory can just be migrated around. And then on the slow devices, we can, debate that all day, whether or not that's actually useful, but it is an obvious use case there. Maybe we don't want that on the standard fallback list. Maybe we just want it in the demotion path. So you can see there's different policies here for different devices, but they all kind of want basic allocation services. So I kind of took a deep dive into the page allocator and MM and, asked the question, what does in the page allocator actually mean? And I came up with this really simplistic example. So pages are members of memory zones, zones are members of memory nodes, and nodes are members of the node state mask and memory. And the default memory policy for pagealloc.c is that if you have pages in a zone less than zone device, for a node in node states and memory, then anything goes. And that is the current state of things. So if there is a struct page out there that is being hot plugged and online in zone movable, the page allocator will happily fall back under memory pressure and utilize that as general purpose memory. And that's really the core of the problem. And, natural question is, what about the existing memory policy mechanisms that we have, like CPU sets or mem policy? CPU sets is good at restricting what nodes can be used, but if you chop a node off of the CPU set, mem's allowed, nothing can use it, period, the end. Like nothing can allocate it because it's just not accessible via the root. And mem policy is mostly not useful for this purpose because it gets ignored by a bunch of things. And it can be overridden by various privileged, it can be overridden by unprivileged user land accesses. And so really what I'm getting at the core of here is it possible to manage different, we'll call it memory arenas, I guess. You give it a different name if you want. Naming is hard. Can we manage different arenas of NUMA nodes utilizing the same infrastructure without changing too much in the core? And I've come up with the idea of managing it with CPU sets, and I demonstrated it using memory hot plug and a GFP flag. I also was pointed out on the list from my RFC that something similar had been proposed in 2017, and it implemented functionally an NSPM node state mask. And these are our, we'll call them different arenas, N memory, node states, and NSPM, which is specific purpose memory. And I think between these two RFCs, which is primarily the CPU set extension and the new node state mask, we have an isolation mechanism that allows us to manage quote unquote specific purpose memory with core services without exposing existing users of the core services to that memory. I realized that was a very long sentence, so let me explain. Basically, if we were to combine these two patch sets, these two RFCs, anyone currently calling pagealloc for memory can never get memory from NSPM. You need the GFP flag to be added, which is really only exposed to drivers and core services to access these NSPM nodes. And so you can think of it as, oh, if something is enlightened and knows about specific purpose memory, it can request memory from those particular nodes, but otherwise they're not in the standard allocation path. And that's really the proposal here. I only have two more things. Layout of how it works. There's three components. That node mask, an extension to CPU sets, MEMS allowed, which allows you to manage both NMemory and NSPM nodes, so you can still have those isolation controls from some amount of user policy, but without exposing the specific purpose nature of those nodes. And then finally, the GFP SPM node, which, naming is not important, but the idea here is when you use that, when that flag is not present, an existing user never gets SP memory, and when the flag is present, it can get access to it. So this essentially creates private memory nodes, which can be managed using drivers or core components. And then from what then? Basically, we push all of this memory policy, if you will, out to the drivers or the components that are enlightened of how to use it, and we keep it out of, Linux MM, essentially. And I think that is a reasonable goal, unless people have strong feelings. And that's what the current RFC is going towards. I need another version to combine these two RFCs. But at this point, questions?
How does this get me to the goal of I just want to use malloc for my device memory?
So it was a good example. I have two use cases here, and I just had a long discussion with some GPU vendors and some compressed memory folks. The compressed memory device, for example, you may not necessarily want to use malloc directly, but you want it in the demotion path for tiering. So at the end of the day, you malloc some memory, and eventually it ends up on the device without any userland policy or any complexity. That can be driven by a driver or driven by a component that knows about compressed memory. On the GPU side, a very simple example would be the driver registers a file-like device, and then you mmap that file-like device. And when the page fault comes in, the driver just goes, page alloc, give me a page from my specific purpose node that I know about and I registered. And so that would look pretty much like malloc or mmap, right? So, and this is where it comes down to, like I said, mem policy is dead, but memory policy is alive. All of those memory policies would still exist, and you could build the mmap interface to it, but without having some like complex NUMA control nonsense going on. Is that a...
What would be the high level interface to obtain such pages?
The high level interface would, so everything I've built right now on the RFC is get page from free list, which, there's a bunch of interfaces into that. So all of those interfaces still apply. And the only change would be a GFP flag and a node number. So it's the same interface.
So essentially you're saying, like right now in the body, we have zone device and it's essentially unused for the body because we say like zone device never ends in the body. And you would be saying, well, we're going to have zone device in the body. And, but you can only allocate from that if you specify a flag that means like, give me one of that special source.
Yep.
And then you get it.
That would be the idea.
Could we run into problems that like for a single node, you might have different types of special because special is overloaded?
Yes. So I've had a short discussion about this previously, and the current design would probably have to imply that you would have one type per node, because otherwise you end up with needing multiple new zones, right? And so I think there's maybe a model problem there we'd have to discuss. I've also looked at how nodes get created at the beginning of time is also a problem at the platform level. Basically, if it's not in the ACPI tables, when it comes up, you can't create a new node at runtime. So Linux would need either a runtime or a boot time or a build time configuration to reserve some of those nodes ahead of time until platforms catch up, essentially. And then they could define like, hey, allocate an extra X number of special purpose zones. But I think that comes down to platforms being aware of the specific purpose of those devices and then making a decision as to how many nodes it needs. Shaquille?
So here in this slide, you have three like use cases. So at the moment you have the interface or the API seems like GFP based flag.
Yep.
I expect like you might have multiple combination of these. A static GFP might not really tell you which one of these.
Yes. So this does somewhat imply that, and I haven't gotten this far yet because I needed more feedback from potential users. This does somewhat imply that we would need to have some kind of like type flag on a node that says what this thing is. And then maybe you could build generic components to say, oh, deal with compressed node. Or if it's like a super special thing, here's a reserved node and don't touch it. And there's a driver that knows how to deal with it. So yeah, that's kind of along the same lines as that. Other?
Can I ask a question? Sorry.
Sure.
Can you hear me?
Yes.
So I was wondering whether repurposing GFP this node would be enough and we wouldn't need a new GFP flag, because if you do GFP this node and specify a node, then it's I don't accidentally without being enlightened.
The biggest concern that I have from an isolation perspective, and the simplest example I can use is if someone were to use NUMA control interleave all, without the explicit GFP, well, I guess it's very possible this node could be reused for that. I think that's reasonable. I'd have to explore it. So thank you. I have to think through the technicals of that.
I mean, the problem I see with the GFP flag is that you run into exactly these issues. Like if you have two types of memory, then you might again need nodes because you need like one node per type. And I think then you're already in the node department again.
Yep.
So, or like, I think the problem is that, like we could talk about having multiple device zones, right? Like within the body, I don't know, like register one, but then you also have to specify somehow how to get from a specific zone in there. And then you need multiple flags. So then maybe we're just recreating what we have with nodes, although dealing with nodes is a bit suboptimal. I can understand.
That's fair. I think we're at time. So thank you.
If you're currently standing up, this is a great time to find a seat.
Okay, next up is some CMA fun.
Oh, we don't see the present.
Sorry, technical.
Take presenter.
Okay, that was too advanced. Thank you. Hello, my name is Juan. I'm my colleague Kalesh. We are working in Android memory system team, and then we're going to talk about CMA. So in Android, yeah, let me see. Yeah, for Android, CMA is very important. I mean, I think that everybody has a mobile device. And then these mobile devices, the Android devices in a specific, 20% of the memory is reserved for CMA, right? So it's very important for us. And then camera, face unlock, fingerprint, use CMA, right? So when we try to use CMA, if it is not available, it's going to crash it might crash the device, or it might crash the application like camera. So we're running into this issue. Like, let's explain the problem. So when we start basically the system, we have page blocks that are free. And for example, we have page blocks like that are movable, page blocks that are CMA, and nobody's using it, right? And as the system, as you start using the device, and then let's think about a process that requires all direct memory. This memory is taken from the movable for the movable page blocks, right? So far, I mean, so good is like the system has enough free memory, so we can allocate from the movable page block orders, right? But as this process start requesting more movable pages with all direct, what is going to happen is like we run out of movable memory, and then we start allocating memory from the CMA page block orders, right? So I mean, so far, I mean, it's like, I mean, there is no any problem here. But suddenly, the user wants to use the camera, and this camera app is very powerful hungry, like memory hungry. So it requests 254 megabytes of memory, CMA memory. And then what it happened is like it tries to allocate the CMA memory, but there is no enough CMA memory, and page migration, it cannot do his work. So what is happening is like this allocation fails, and then it's like we cannot start the camera. So.
Oh, now I will go over a concrete example that happens in Android. So in Android, when we do OTA updates, we need to read a lot of different partitions, and we do this using ODirect because we don't want to pollute page cache with gigabytes of pages that we're only going to use once. And just after boot, we have to do a lot of reclaim. So when we use ODirect for this memory, what happens is we call this problem rolling blockade. Is like there is a lot of pages pinned temporarily for the ODirect IO, but yeah, no page is pinned for a long time. But because you have a cascade of pages being pinned one after the other, the CMA allocation fails. So yeah, this problem we have seen, it can cause like for multiple seconds of even the allocation will fail. So yeah, the next thing in Android is that because we have so much CMA regions in some devices, we try to utilize that memory, because what happens is there's so much memory reserved for CMA and non-movable allocations may begin to fail, even though we have a lot of free CMA areas. So in Android, we have some out of 3 hacks to increase the utilization of CMA. So one is that for alloc 0 user high page movable, we patch this to use GFP CMA, and for ZRAM allocation, we also want this to use GFP CMA because we don't want reclaim to fail, even though there is a lot of CMA memory available. This does improve our utilization, but it causes other issues. So for the ODirect issue, there was an RFC sent upstream to attempt to fix this, which was to use full long term for the direct IO pages so as to not be allocated from CMA, but it was rejected upstream because of the full IO. Full long term is for exactly the opposite case of direct IO. So there is a semantic problem here, but we agree with upstream consensus, but we still have this denial of service in the embedded device. Some other workarounds that we have for trying to make sure the CMA allocations don't fail on Android is we currently try to wait for temporarily pinned pages to become no longer pinned. So in CMA range alloc, we wait the 100 millisecond timeout for 5 total retries. But even with this, we can see CMA failures in the field. And I will hand it over to Juan to raise our discussion.
Yeah, so basically it's like there are several, possible alternatives to solve this problem. One is proposed by David Hildenbrand. So the solution, the solution consists is like once that the page block has been isolated, and we want page migration to make progress, we can stop the GOP allocations either by waiting or basically it's like waiting so they don't request more pages and then let page migration do their job, right? That's one possible alternative, and the other alternative is like basically banning some certain types of allocations from fallbacking into CMA, like for example the ODirect allocations, right? And another more like an alternative is to create a new migrate type, like migrate CMA strip. That what it means is like you cannot fall back to this type of migrate type. Yeah. So yeah, these are some of the possible solutions that we are exploring. And yeah,
Have you considered stopping using ODirect? So for the last excuse me, for the last year or so, we've had the drop behind flag. So you can specify that you don't want this to pollute the page cache. So you use the page cache temporarily, but as soon as the IO has finished and you're not using the page anymore, it gets chucked out of the page cache.
We haven't explored that situation, but the problem with the OTA updates is like we don't want to use the page cache because we know that once that we load the data into the page, it's like it will never be used again. So we don't want to give that extra work to the page cache. We just want to use and don't.
That's really what PG drop behind is for.
Okay, so we can
just temporarily use the page cache.
Yeah.
Yeah.
It really is a you use once and it's gone again.
Okay, yeah, we can try that. Thank you. Yeah. Another thing. Oh, sorry. Question. Okay.
Yeah. I really strongly agree with that ODirect thing. After spending some time with it, it's really not meant to be used for this. But also that first item should be fixed. I was gonna do it, and I tried it and found out that it's kind of hard, and so I didn't do it. But it really should be on the list. So if you've got folks that want to look into that, David had a great suggestion, which I think you got there. I failed to implement it because it's actually hard to find the right thing to wait on. I think the latest idea is to wait on an actual page block. Not quite sure how that works, but that's the proper architectural solution to that corner of the kernel, in my opinion.
Yeah. Got it. Also, another thing that we want to bring to the table is to debug these issues. Literally, it's like we spend like 30 minutes, like to 1 hour, to have the setup, for example, to simulate the OTA update. So what I'm working in order to make these issues more debuggable is like to add a module in debug FS, and then it's like literally you can allocate any page from any node, any zone, for any order, just for debugging purposes. So I wonder if there is some appetite upstream to have something like this in debug.fs, or it's not useful. I mean, for us it's useful because it's a pain in the ass, like trying to literally to allocate 10 gigabytes of memory just to create a memory pressure conditions.
Would that, for example, if you allocate from migrate movable, would that allocation actually support page migration that you wouldn't otherwise just break page migration? Like the allocation you trigger, would that support page migration?
Well, I mean, the allocation could be through the body allocator. So literally, we will use the body allocate for movable. We will use the body allocator, but for CMA, we will use the CMA alloc too.
Right, but if you allocate, then like page migration would have to know how to move that reference, and I assume your code would only allocate it, wouldn't actually know like how to plump into page migration code to move around, right?
Yeah, no.
Okay. I mean that would probably be helpful if you could do that. Because then you can actually simulate what it would be like if you actually have like a page that's movable. You DMA.
Yeah, and the reason of this is because it's like every time that we get a bug for this, it's like we tell all the steps, look, give like 10 steps to try to reproduce the issue, and it's like, okay, it's very painful. So with this, it's like literally you say, okay, I want to allocate 2 gigabytes of some, I mean, some movable order 8 or something. Yeah. Is there any other questions? Yeah.
Yeah, I mean, I agree with what David said on implementing the migration bit, but I have lots of tests that I run that would be very useful that we try and test with out of memory conditions and memory pressure. And yeah, as you say, it's hard to do that at the moment. So I mean, it would be useful for me.
Okay, that sounds good. Yeah. Is there any other question? All right. All right, thanks. Thanks everybody for the suggestions.
All right, I guess this is the point where the huge page stuff begins. So next up, Ackley. I'm gonna activate the slides in a second.
Hi, my name is Akali and I'm on the confidential CPUs team at Google. My team makes Cocoa VMs available on Google Cloud. So recently I've been working on huge TLB support for guest memfd, and hence this talk. So to put the ask up front, what we would like from you is your thoughts on making folio restructuring as in splitting and merging, orthogonal to THP and huge TLB. And I'd also like to gather some other use cases for folio restructuring and try and make this as generic as possible. So now I'll step back for.
Well, okay. Since you put the ask up front, could you just go back to that slide? Sort of the point of huge TLB is that it doesn't do, whereas THP is supposed to be quite dynamic. Huge TLB is really supposed to be static, with some very, very minor exceptions, like we had memory poisoning. There's actually a hardware problem, and so we really have to take this folio out of huge TLB and do something else with it, because it can't be a huge TLB anymore because it's got memory errors in it. But so I don't know. I don't know. Your first ask is reasonable.
There is something called demotion
for huge TLB.
Yeah, where you can say I have a 1 gigabyte folio and I want to instead have 512 2 megabyte folios.
Okay.
Yeah, I guess we have guest memfd has a rather unique use case, I guess, and we are making use of UHTRB. So maybe these slides will talk more about that. Yeah, so guest MemFD, I'll step back for an introduction. Guest MemFD is a guest first memory provider built for KVM. It's for virtualization. And this is the only supported memory provider for guest private memory for Coco VMs. So it was first built for confidential virtual machines. And guest MemFD has one core principle, and this core principle is that guest private memory must not be accessible by the host. So there are we see it as two kinds of memory, the shared and private memory. Shared memory can be accessible by the host, private memory cannot. And so to implement this, what we do is we remove or disallow mappings in host page tables. And the logic here is if there are no mappings, then there are no accesses. So this ties into how HugeTRB is used here. So guest MemFD, it uses other allocators to
Hello, hello. Are we good to go? Okay, cool. So I'll just start where I left off. So what actually happens when you enable zone reclaim mode is if you're on a system with multiple zones and you run out of memory in the local zone, what should the kernel do? With it disabled, you just kind of fall back to the next zone and try to allocate memory from there, whether that's on a remote node or not. But with it enabled, you just engage direct reclaim on the entire node. I'll kind of clarify this later on, but the basic summary is that you try your best to allocate memory from the local zone by reclaiming the current node. And so my goals for today, number one, find out if anyone is still using this. Number two, determine, kind of come to a consensus on whether we can deprecate it. And if we do agree, how we can move forward. I also want to be explicit. I'm not saying that zone reclaim mode is bad for all workloads. I'm sure there are cases where it's actually quite beneficial, but for most workloads, it doesn't make sense. And for the ones where it is beneficial, I think we have better alternatives now. So when is it harmful? First of all, when the cost of direct reclaim is greater than the remote access latency. This whole principle is that we don't want to incur the cost of remote access latency, but if it costs more to reclaim directly, doesn't really make sense to do that. Second of all, if you have a system with mixed workloads, so let's say you have some that benefit from zone reclaim mode, but some that do not, well, you're kind of out of luck because this is a system-wide setting. You have to set it for all workloads. Last one is if you have a NUMA node with more than one zone. Now, this is kind of confusing because zone reclaim mode used to actually be called node reclaim mode. But now what the policy is if you have a node with one zone that runs out of memory, you go into direct reclaim for the entire node. So if you have a mix of zone movable and zone normal, if one of those goes out of memory, the whole node kind of goes into reclaim, blocking all allocations. So some numbers, right? If you have a mix of anonymous and file cache memory, in this example, I have 60 gig anon and 100 gig file cache on a 2 NUMA node system where each one has 125 gigabytes memory. You can see that with zone reclaim mode enabled, the performance is quite abysmal. I mean, part of it comes from you kind of getting rid of valuable page cache information that you have to fault in every single time. And the other one is just the cost of doing direct reclaim. So this is one example when it's harmful. Now, when can it be beneficial? One thing I can think of is if you have very latency sensitive workloads that really don't want to incur remote access latency. I can't think of any other workload. Maybe you all can enlighten me. And we actually do see the numbers here. If you have something that is very memory bound, latency sensitive, same setup as before, but now we're doing random memory access. You see that we do actually get a lot of benefit from doing zone reclaim mode, trying to keep the memory local, preventing the remote access latency. But as I mentioned before, we might have other better alternatives today. One example I can think of, if you really want local memory, just membind it to a node. And you can see in the second row that we actually do get better performance than a zone reclaim mode. You might also be wondering, it's a toggleable feature. Why not just let the user decide this? Why do we want to deprecate this completely? There's a maintenance burden. There are 3 syscuddles related to this. There are 2 other ones that kind of determine when you want to go into direct reclaim. But we also want to prevent users from making suboptimal decisions if we can show that there are better alternatives for every use case where it performs good. And finally, I'm a little biased towards this, but it simplifies the page allocation code a lot. We can get rid of about half of the watermark allocation checks. We can get rid of a lot of functions that are related to zone reclaim. So hopefully this excites all of you all as well. And so try to keep this short so we could do discussion. If there are people who are still using it, who want to kind of show me where it can be beneficial, I really appreciate that. But if we agree that this is the right way forward, how should we do this? I've never deprecated anything that's user-facing before, so hoping to get some insight there as well.
That last one I can actually speak to because I've deprecated user-facing things before, which is you leave them in place and they become no-ops, right? So if somebody opens it, writes to it, we don't care. And I actually find that quite useful, right? Like, people think it's still doing something. There are still articles being published that say, hey, you should mount your NFS with the INTR option. This has been a no-op for 20 years at this point. So I always really enjoy reading those articles. But I mean, we could. I mean, they're syscuttables. We could delete them entirely because programs ought to handle their non-presence gracefully, and it would tell the user that they're on a system that doesn't support it. But I think it's probably best to just leave them, make them no ops.
I think the problem can be that if you have an application that was written like long after a feature was introduced, that it just blindly assumes it's there. So you could break applications just like letting it like go reads and writes to it, but not doing any logic. I think is the easiest way.
No warnings, just no ops. Okay.
No, I mean like if it makes stuff faster, right? So why would you can print like congratulations, like we saved your system. But I'm actually wondering about the use cases. I mean, like for sure this thing was introduced by somebody who showed off like quite some valuable use cases. Do we have the feeling that all of these use cases have in the meantime been like improved otherwise, that you can be like 99% sure that there's nothing left?
So 20 minutes ago, I got a response on the RFC code that I posted of someone who uses this for high performance computing. I don't think they're here today, but sometimes you do want to prefer local memory. Now, I think this is a little bit of a confusing use case because from my perspective, and I think the kernel's perspective, either you want to keep memory local or you're okay with having it remote. There's no option to really say prefer local as much as possible, but I'm also okay with fallback allocations.
So Lastar writes, wasn't Google using this mode? Is somebody from Google here who can confirm? Maybe for some corner case, but then the question would be like, are they really fine-tuning the value, or is it just like some fixed value and you could have like a config knob for that to just say, well, like I'm going to change, I'll have like the option to change it for a running kernel, and we don't need all of the complexity of runtime configuration and all of that.
I think, so on the configuration part, the two things you can tune are the minimum slab and page cache ratio that you need for node reclaim to actually kick into effect. I don't know if anyone really uses that to tune. Oh, Balbir remembers why this was introduced. So actually, in the meantime, maybe I can also say, like, this was actually enabled as a kernel feature. It wasn't even something that you could toggle, but then it got turned into something you could toggle, and then eventually it just became turned off by default.
Apparently, the cost of page cache reclaim was high, so fallback was more expensive. And Balbir, you can speak if you want, I think.
Hey, I'm just testing my audio. Hopefully you can hear me.
Yeah.
So what I remember is that this was a long time ago when you had expensive NUMA boxes, in the sense that the cost to going to a remote node was very high. And because page cache was treated as an easy reclaim target, it was considered better to reclaim from page cache than to allocate from a remote node, which is very expensive. And so the idea was to almost do reclaim, but do it on a per node basis, to treat them as like almost an independent system. And
I think that makes sense.
And I suspect some of those systems still exist today. Like there are systems where the cost of remote nodes are still very high, and this is still useful there.
I see. Kind of putting it on the same note, like I guess tiered memory could kind of treat the same way, where like remote memory access is really a second memory tier, and you want to be. I don't think I touched anything.
It's not your node.
Oh, okay. If you have tiered memory where like remote memory access latency is kind of equivalent to like going to a lower memory tier, I can kind of see why that would be a valid use case. But then again, I think memory tiering makes more sense. If you're talking about like systems where there is like genuine NUMA distance, why not membind in that case?
Yeah, I think that's a good point. I suspect membind means every application needs to membind. Whereas with something like this, you could use this like a system-wide knob, which is sort of what it was intended for.
I see. I'm really happy to hear this. If there are genuine use cases, I think there are ways to work around this where we actually improve the way zone reclaim mode works. Something that I want to clear up is like, I don't think it makes sense at all for a node to go into direct reclaim if one of its constituent zones runs out of memory. So maybe that's some behavior that we can talk about.
So you point out here that membind is actually faster than zone reclaim mode 7. When you set zone reclaim mode 7, can fallback allocations actually occur?
Yes. So this is actually one of the things that I also think doesn't make sense. Like when you have zone reclaim mode, you go into direct reclaim, but if that doesn't reclaim enough, you just still fall back to the next zone in the zone list anyways. So it doesn't even guarantee that the memory stays local.
Okay. I guess that's a reliability feature in this sense. I was going to say, is there a potential for just zone reclaim mode equals 7 being set to membind, but that would not allow fallbacks, right?
Yes, that would be different behavior.
Although if demotion's on, it would effectively be the same thing. So yeah,
Hmm.
so that's possibly an option.
I think one thing we'd have to figure out is currently this is a system-wide setting. So if we want to have some sort of like membind-like interface, we'd have to figure out which zone it's trying to, or which node it's trying to stay local to. But I think that makes more sense than turning this into a no-op. Thanks. If no other discussions, I will yield.
To swap.
Hello, I'm Youngjun Park from LG Electronics, here with Chris Lee from Google. Today, we are gonna talk about per C-group swap device control. Let's dive in. All right, let me give you some background why we are even doing this. The platform optimization in my company, so faster swap assigned on latency sensitive C groups, slower swaps assigned on non-critical C groups. I want it, but Linux allocate swap globally, not per C group. To solve this problem, my initial approach was per C group priorities. But as discussion from LKML, there are two problems raised. This is over-engineering beyond practical needs. Actually, our use case need just inclusion and exclusion semantic. And there is error inversion across C groups caused by differing priorities. Based on slow swap devices appear at the tail of error list. By discussion, the swap tier concept is suggested by Chris Lee. We discussed and refined it together. I think this concept is simpler and extensible concept, covering our use case. So the concept. So what is exactly a tier? The simple definition is this is a user-named group of swap devices sharing swap priority range. You can see the picture. We've got tier network from the left side and tier HDD and tier SSD. This is configured by CSF interface. All tiers is divided by priority ranges. So the network tier, the minimum priority is -1, so -1 to 40. And next, the tier HDD, 41 to 100. And tier SSD, 101 to maximum priority number is short max, so short max. All priority. Sorry.
You're shouting.
Oh, okay. Sorry. Yeah. So, yeah. So all priorities are covered. So I think that this is good abstraction layer facilitating swap device selection based on swap speed. But as you know, user can choose have a freedom to select a priority, but this could be a good facilitating layer, as I think. And so for per C group swap control, we can make C group selector tier. Then C group only uses swap devices from allowed tiers. So I can introduce the rules, how C group can choose the tiers. So there are two types of operation I define. One type of operation is default tier operation. This is the inheritance control. So empty string is the inherit parent, and process ignore parent, start from all tiers. And minus is ignore parent and start from the zero base. And the second type of operation is tier per tier operation. This overrides the default tier operation. So plus specific tier, select specific tier, and minus tier excludes specific tier. So I talk about the rules, and I'm going to talk about consequences.
Oh, I know. Rules and consequence.
Oh, yeah. Sorry, Chris. The consequences I'm going to talk about is evaluating the rule in allowed tiers. So you can understand easily what I said. The root to C group, the default tier operation is plus. So as you can see, all tiers are selected. So this is serviced by all swap devices. And C group 1, no default tier operation, so no inheritance, just minus network, so overrides it. So it is serviced by two tiers. If you add the minus SSD, it only is serviced by HD tier, so the swap devices. And CG2, default tier operation is, plus. So from the all tiers, it disconnects the inheritance and minus HDD. So it's serviced by two green light tiers, and CG3 minus exclude all tiers, and plus network. So it only serviced by network, tiers. Next part is discussion part.
So I will take over the discussion part, and we have prepared some question list, but I would love to hear you guys first on what question you have. Perfect.
Simple question. Are there any other interfaces in C groups that allow a child to ignore a parent's configuration? Yeah, go ahead.
Currently, I'm not aware of that, but that's a very good question. It's actually one of the consideration is that a lot of our current C group, they are designing for resource limit.
Right.
So they follow a strict mathematical rule that the parent contain more resource than the children. So it doesn't make sense for the children to have like more bigger resource than the parents. So it's always restrictive. But we are arguing that this is a special case. It's more like a policy. We want to have a quality of service. So we do see the need that the child might prefer a more aggressive policy, like faster or slower than the parent.
So
and it doesn't have that.
I ran into this with the SPM node interface that I was talking about. I ended up having to split MEMS allowed into a default set, which is restricted by the parent, and an allowed set, which is also restricted by the parent. But both of them have separate controls. And that allows for example, you can set the parent to allow everything, but then have the policy component restrict. And then the children, by default, inherit everything. But it may not carry over. My point is really that if this is the one thing in C groups that is the special case, that's a little odd for it to be in C groups then. Even though like it wants to be a C group control because of what you're trying to do, but if it's the only thing that allows for override of parents, it just doesn't seem like a good fit.
Yeah, we also had something that came up, THP, I think, related, where someone wanted to manage THPs in C groups, and the answer we got was it's not a policy place.
Okay, and what would be your suggestion if it's not a C group?
Oh yeah, I don't know.
Yeah,
I mean, PRCTL is where it ended up going, I think. I mean, and
I
that's
think
just really not somewhere you want to go.
The reason we want that to be a C group is that we do want to support something like Kubernetes or like the C group control job scheduling kind of side to able to control this swap device.
So we have two more questions. Balbi raised his hand. So
Okay.
Balbi, you go first.
Yeah. My question was, why are all of these in the same C group? Like, if you really want different swap devices, shouldn't they belong to different C groups?
Oh, of course, it can be different C groups. I think the example is only giving one root C group to demonstrate how they override or interacting with the parent. But definitely, we can have more examples to show that they are totally not related C groups. That's possible as well. It's a limitation of the example we give. It's not a limitation of the mechanism.
So let me looking at the swap tiers in isolation. Like I would like to see this as a memory tier, like the journal tiering solution, because the setting aside the API and whatever the behavior, I think it should be kind of like what's the coherent story behind the journal tiering. And I would like to see then what's the memory tiering and the C group, and then the swap tiering if you add. And the second on the as everyone's saying, C group, adding interface for these things. I would suggest go with. I think this might be a very good do in actually in the BPF world way to do selection these things, rather than adding an interface and adding more ways to configure these things. So if it can be done in the BPF, that would be the great. But the second, again, going back, I would rather first see how this fits with the journal tiering, the story.
So your first question first, and you would like to see how they fit into the bigger tiering story. Basically, you want to see how do we move data from one tier to another, and etc. Yes, those we have plans to do it in the future. But right now, we starting from allowing to select which one, current one, we haven't done the moving between the tiers yet. But I really want to agree. I really want to see that happening as well. It's basically moving the swap data to another tier, and the swap file will behave more like a file system, basically to allow them to do swap operation or swap ops kind of API with reading a swap page, writing a swap page, or maybe each of them can have their own way of allocating a slot and stuff like that.
So I would rather if you can do that without introducing any API, then I I can think about it. We can think and say it might work. But if you add the API, then it becomes very hardcore. No one can then change it, right? So before introducing anything, I would like we have planned out the whole how we see the whole end story here.
Okay, and just to clarify your question, you would say that you don't, you will, before we introduce any API, do you mean user space API or, yeah, okay, yeah, sure. And then, but the kernel API, I think is definitely unavoidable to add here.
Sure. The second question on the, what is my second question?
Yeah, I forget that.
The BPF way, I think if that can be done, that will be I think the best. You don't need any API.
I think there's certain overhead with the BPF. I would imagine if you are doing Kubernetes control and you probably want to have a unified way to do it. I think a straight kernel interface is easier to, if it's at the base infrastructure, it's easier to use BPF. You need to compile your own BPF module and load. They have their side of overhead as well. I think we can. Yeah, I agree. We should probably prototype and then maybe set as experimental for a while and then see how much people would benefit from it. I saw 1 minute and maybe one.
I think we can take one more question from John. John,
yeah.
Or did you comment?
I just want to can you go back to your slide that had CG 1, 2, 3 nested?
Yes.
Yeah.
This one.
I feel like you've kind of created a bit of your own problem there. I think if you relax your constraint and stop saying, well, we have to support this ridiculous thing where somebody's got a nested C group, but they want to override. I mean, because my concern here is that you're creating an API that violates the way you're violating inheritance, and yet you're saying we still want inheritance, but we want to be able to arbitrarily override it. So I think you'd be better off not using this this complex system of plus and minus and override. Instead, just say, you know what, if someone has a C group, it still follows the C group inheritance rules. We're not going to try to override that, and then just find a way forward with that. I really don't think this is a good idea from a design point of view, the ability to arbitrarily override at all levels. I think if you drop that constraint, you can still get where you're going.
You are basically saying that removing the override, like basically the plus and minus only without the
don't play games in the hierarchy.
I think, and then we would need to have a way to support like either the child faster than the parent or to be slower than the parent, because both direction can happen as a policy.
We're at time, but I'll just add this. I think it's also possible to restructure your C groups to just allow this to just work without adding the override.
Okay, yeah, let's talk offline. Yeah, thank you.
Thank you.
All right, we're gonna meet again in half an hour. I think there's a break now. So 5 p.m. be here. Don't miss out the good stuff.
Anybody else?
It's so overwhelming out there. It's so overwhelming out there. I went to like really find a quiet place. I definitely wanted to do that. Here's quiet.
We're going to be starting in a minute. Now would be a good time to find a seat.
Right. Edwin.
Exactly on time. Hi, I'm Case. I don't have a ton of slides here, hoping for discussion, or if there's no discussion, then I can just get this committed immediately and there will be no problems whatsoever and no one will object. This is about some of my work on this idea of k-malloc object. You get the slides there. Fundamentally, this is about getting the slab allocator to be type aware. Right now, we entirely allocate based on size, and that means we don't have type information for the return value, like we return void star. So we can't do any checking on that. We don't have any information about alignment. We can't do anything related to, extended type information, like for hardening and creating, buckets of types and other things. There was a talk earlier in the tooltrain track about a similar idea about this. Both solve sort of the same problem, which is we don't have type information. In the toolchain track, the idea was if we can't change the kernel's allocator, maybe we can have the compiler guess at the type, and then we can do stuff about it. And I'm taking the approach of let's change the allocator since we actually want to use the type definitively in lots of places. And this is mostly about making that change, not necessarily what we do with the type information, but we will have it available. One of the first things that happens when we make this change is just getting distinct type safety. The value being returned is a pointer to the struct you wanted, as opposed to void star. And in doing the tree-wide change that I found like a handful, like 6 cases of what was being returned wasn't what was on the left side, so they weren't the same type. All of them were accidentally correct in the sense that they were either the same size or larger, so yay, that was good, but I don't want that to go wrong. So those are the kinds of benefits we would get from this. So the V5 series I posted last week with a hilarious subject typo, but this basically gets us the before and after view of what we convert from. In all these cases, I'm saying, well, I have the second example says struct whatever in it. So you can either use a variable instance or you can use a type. It just does, internally, it just takes type of and is happy to do whatever. This allows you to do, this style or the, now Linus approved version of using auto. You can declare the variable you want and put the struct on the right-hand side as part of the allocation. So this is about us getting an object of a given type, including arrays of types and ultimately even flexible arrays where you have additional information off the end. Excuse me. One of the interesting things about this is we can actually automatically assign the counter for annotated flexible arrays because we can query where and what type is the thing that counts the size of the flexible array at the end and actually set it in the allocator. So the allocation becomes sort of I shouldn't use atomic in this audience, but it becomes a single operation where you get the object out with the counter set, everything is ready to go. This is handy because we can fall back in an unannotated case. It says, we don't know what we're pointing to. We have no counter for this. Yes. Oh. Why would you want to use auto? Linus has a whole long thread on this about auto, but there's a bunch of handy situations where you want the shorthand of just like, we don't care about declaring the type over there because we have it in multiple places. One of the problems with, if I go back, like on the second line on the new side, I have k-malloc object struct something. Like if this were fully typed out with pointer somewhere else declared, you'd say struct something star pointer equals k-malloc object struct something. Like you've repeated this again, and we have this problem even now with k-malloc because we do size of the type or the size of the struct or whatever. So this repetition of that type information it's just redundant. And so there's been a push, and this came up. The thread that Linus was in came up as part of scoped guards, where we want to have a variable declaration within a scope, and being able to to have variable declarations not at the top of the function anymore necessarily. Like if you have a good reason, you can declare them somewhere else in the body. And then Linus sort of went on a tangent about using auto. And that also created a question about auto versus underscore auto type. And we just had a series, I think it landed, for fixing all this so that we can just use auto as the common macro across the board, even if we're not in C23 mode yet. So we just have a common way to do auto types. Yes, does the flag. So I talked about this already and the magic of this. What I was talking about at the end was if an annotation doesn't exist, the built-in just says it doesn't exist and the allocator just skips it and it gets elided. Someone have the throwy.
Maybe a little bit of a tangent, but is there a security or reason that we should discourage people from using signed counters for things like this?
So the signed counters, because we have such things, we also have counters that are signed to indicate things other than the size of the flex array, like error conditions and other stuff. So to avoid having to completely fix all these and make them all unsigned, if a signed counter has a negative value, it is treated as 0. So any negative values on the signed side are 0, as treated by the bounds checker and by the asking the size of the dynamic object.
So my follow-up was, if you're introducing like this K-malloc flex, would it make sense to have some magic to discourage signed counts?
Oh, to discourage it.
Like not enforce it, but discourage it as a cleanly, because I see often people using int just because it's 3 letters and they don't think about what they're doing.
Yeah, I don't see any reason to strongly do that. I mean, it's fine. We could have check patch do it. We could add warnings to the compiler to just go, why? It's signed. Like we could do a lot of options, but on my view is like, how do I disrupt the kernel as little as possible when I am so terribly disrupting it to begin with? U32 is yes, U32 is also 3 characters. Yes, I almost said that. Yes, size deking it big. Anyway, so yeah, that's it. The whole thing is in the series. Just sort of like, is this acceptable? The V5 is significantly simplified based on Linus's feedback, because I had macros doing horrendous things for a very small corner case, which turned out to be like less than 1% of allocations in the kernel. You want to know the size of the object you've just allocated. And you can just figure it out again the way you were already doing it prior to using, when you were using K-malloc with a size, you had to calculate it before, so you just do it again. I'm not super happy about that, but it really does simplify the macros. The macros went from 12 lines of insanity to 2. Like, it's much cleaner. We also need to handle devm K-malloc, like the devm wrappers. I didn't do that yet because I had been getting a lot of let's completely redesign it feedback for a while, and I didn't want to continue redesigning lots. So the idea would be, if people are happy with it, then we can extend that to devm and other things. So that's it. What was that? So we can do it. I extended. Did I do vmalloc? I can't remember. I think I did vmalloc because I think I also did the kvmalloc wrappers as well. So I did kvmalloc, so kmalloc, kvmalloc, and kmalloc. I'm pretty sure I did. Apparently, I don't even remember my own series. But those wrappers didn't change when I changed the core functions. But yeah, we can do that. I have had some people say, well, what about the page allocator? I'm like, that's sort of like a bulk operation. You're asking for pages of stuff that's not really typed. Whereas the slab allocator was sort of designed for, I need an object. I need a thing out of memory somewhere. Give me a thing. It should be a typed thing.
Just curious. I think you didn't have an example with slab caches, right? Or did you? Or
out of like the predefined slab cache?
Yeah.
I didn't, because those are actually typed.
Okay.
Well, they're not exactly. They're sort of typed. Like you have a size, but you can do things. I didn't do that just because those are already pretty well, like you can declare alignment, you can do other stuff. So if we need, when we plumb type information or alignment information, we've sort of already got that on the slab, on the KMM cache side, we have that information. So yeah, I don't have an example of that one. But if we want it, okay.
I mean, would be a consistent interface then, but
yeah. Sorry, I was just reading comments on int, unassigned int getting switched to int to be more congruent with surrounding code. So again, U32, very short. Anyway, that's all I've got. Any other feedback or questions?
No, not really feedback on your patch set, but for all of the other people returning void pointers in their code, is there a certain thing we should be doing? I mean, I've been encouraging people to make wrappers for each individual thing. Is there something that I should be doing? Should I be encouraging auto now as well?
Oh, yeah, I have no opinion about auto.
Right. Yeah, but other things like that.
Yeah, I would generally discourage void star returns. Like I don't.
Yeah, so you have
I want it typed.
Yeah, well, I mean, but then you have, a tree that does everything, and then people have other things they're putting in there. So you're returning a void star and you're saying, okay, be sure that you add your own wrapper.
Right.
Right. And now I have a monster. So how would you recommend to not having the monster?
I would like to look at some of those monsters. Like we have some wrappers, like a dev-m is not subtle. Like it's going to take some work to make that work sanely, just because it's got its own information tacked onto the front, which makes alignment fun and some other things. So I'd like to look at some of the other wrappers. Like if you have some examples of this, I'd love to take a look at it, just because most of what I did was on like the gigantic 20,000 calls to kmalloc tree-wide change to make those work correctly. And those were mismatched in a couple places, like I said. But yeah, I'd love to see what examples you have of that, just to see what problems there might be.
Yeah, I mean, I guess in my situation, it's not just allocations, right? It's operations that need to be mapped to particular internal operations as well.
Okay. I'd love to see it.
Okay, thanks.
yeah, just like while we were talking about it, like what I recently found is that we have some of these mechanisms like notifier callbacks or things like that, where you just punch in a magic void star and like then like you get the information back out again somehow. I was just wondering if there would also be other ideas on how to do that. I guess like the C++ way would be using templates and stuff like that you create your own special version with the type. But
yeah,
I'm just curious if like you could think of something.
I'd love to take a look at the examples, because in the case of callbacks, we've usually been able to use like actual function pointer, like actual function prototypes to cover that, and types that we don't know of. Usually you're using container of to get at the wrapping type in your callback, so you don't need a void. Like we've played a lot of weird games in the kernel over the years for this, so I don't know. I've seen a lot of solutions, so I'd be curious to see what the specific is, because I think there's probably an existing solution we could work.
Yeah, but like what I'm thinking about, for example, is like a weird page walk API where we walk page tables, and then like you have your callbacks, right? But you want to pass some magic data into these callbacks, so there you go, void star,
right?
Deal with it, and it's just very weird when we talk about type checking already.
Yeah, that one, yeah, as an argument to a callback, that one is just like, enjoy your void star.
Oh, Lastar said that he absolutely does not want your stuff. Oh no, he said that he's fine.
It's fine as long as Linus says, yay, okay, thank you. With 1 minute left, that was through the line. Okay, cool. Well, thank you for your attention. I'm glad it'll work.
How long ago did you work there?
So I have a special announcement to make. Apparently, Lee Alvin, you have no passport anymore. I guess that's a bad thing. So if anybody knows him, just tell him. He's from Meta, so I can identify now as a Meta employee. Oh, understood. So, can I give it to you?
Hey, apologies for that. I thought I was on at 6, but. Hey, so I'm Alistair from NVIDIA, and I work a lot on sort of our GPU virtual memory manager. And so for the last sort of, I guess, 12 months, I've been working in this zone device space, trying to get that working a little bit better in the kernel, a little bit upstream. So I realized I probably haven't put enough background on this introduction slide. So for people that don't know at least what our interest or use of these zone device private pages is, it's essentially a way of taking anonymous memory that's mapped on your CPU and system memory and being able to migrate that to, say, a PCI attached discrete GPU. And the point of that is to allow sort of this pointer as a pointer type programming model where you say, hey, we called malloc in user space, we got this pointer back, we'll chuck it over to the GPU, same pointer, and do some computation on that. And sort of magic happens in the background to migrate the data locally to GPU video memory so that the computation runs appropriately quickly, and you get some quicker results. And that's kind of what the zone device private struct page is specifically used for. It holds all the metadata for that migration. The data obviously lives in the actual memory itself. So the important points about it, I guess, is like it's mapped using special PTEs, which means that it's not mapped into user space on the CPU side. And so what happens is, if you try and access it from user space in the CPU, you take a CPU fault, the driver migrates that data back using, driver-specific calls to use DMA engines to drag all the data back into system memory. So it's kind of used to represent that unaddressable or inaccessible memory from the CPU. And so the only way data ends up there is by driver-initiated APIs. So yeah, hopefully that's a quick overview. If you want, some more details, certainly grab me afterwards. But sort of I'm here to quickly talk about some improvements that sort of we want to make going forward to the way that's implemented. But quick recap of progress from LSFM earlier this year was that we were in the middle of cleaning up some of the ref counting issues that we had there. All zone device pages had this off by one ref count, which made transparent huge pages hard to do. And that was, what we needed for our next improvement up there is, currently device private pages only support 4K or CPU sized page mappings, which is a real performance hindrance for GPUs in particular. They much prefer to operate at 2 meg page size because THPs, they consume they suck down and compute over lots of data. So, that was the motivation for that. I believe that Belbeer has managed to now get that patch series merged as of earlier this week. I think it's in RC1, 619 RC1. So that's some really good progress that's unlocked. And now we're sort of starting to look at the next next round of improvements that at least we need as NVIDIA for that, for this infrastructure. And so the main problem that we're having at the moment is that device private pages kind of steal the physical address space. We use request region to basically go, hey, we need 10 gigabytes of physical address space in the CPU linear map, and we'll just sort of map pretend pages to that, these pretend sort of device private pages. And that sort of works on x86, has a bunch of problems with Caslar though, and sort of we run into all sorts of other strange bugs because no one really expects the kernel to just go, hey, we're going to steal all these physical address bits for you. Other platforms like ARM64 kind of doesn't work at all there, or you have a very limited amount of direct map space. So 10 gigabytes maybe you can get, but you plug in a big GPU with 80 gigabytes of memory and it just doesn't work. And one of the other issues that we have also often run into is this initialization of the actual struct page metadata itself takes, of the order of, tens of seconds, so up to 30 seconds, I think, for about an 80 gig GPU we've had, which is, that's a hindrance for initialization. So we're kind of looking at ways that we can improve that now, and in particular, get the ARM64 platform support working. And so that's sort of comes to the heart of like, well, why do we need struct page? That's not representing CPU memory. It's obviously representing device memory in this case. So what's it actually used for in the kernel? And one of the big use cases, of course, is page to PFN and PFN to page, which is a way of just, looking at, we have this PFN mapped in the CPU page tables. You need to convert that to a struct page so that the kernel knows what to do with everything there. And we need to be able to go back from that. And I know Willie said that he had concerns with that design initially. That was probably a bit before I was around looking at the design, but I suspect probably that was done in order to reduce the amount of special casing we needed in the kernel. I'm not really, but as I said, I don't have the history there. But the observation is that, or that we've made, is that like really you have to special case every single usage of these pages and these entries, which sort of led to this thought that like, hey, we can, if we have all of these special cases, why do they need to be real PFNs to begin with? Couldn't they just be some index into some linear array, and we can just allocate a huge array of struct pages and stick that as an offset into the special swap entries? Because essentially every time you have, you take that CPU fault on this special swap entry, you look at that and go, oh, this is a special device swap entry. Rather than use PFN to page to get the struct page, just go device index to struct page to get that. Because you always know you've only found this entry from the page tables, and vice versa. If you're installing an entry for one of these struct pages, you by definition know that it's a device page. So sort of it's unclear why we ever really needed the page to PFN and PFN to page aspect of this. Some of it is that it is hard to sort in Linux MM to sort of find all of the page table walkers and who's using them and what it is. I'm sort of positing that like, if there is no special casing today for the device private page, you've probably already broken. But I think
that would be my assumption. Like anything that treats that like as an ordinary like PTE would be broken already.
Exactly. So if you've already sort of used this swap entry to page and you're not looking at the page, then what do you? Or if you're trying to use that PFN as a real PFN, well, you're already off the rails. And
you should be breaking these cases so we can identify them.
Exactly. And I don't think they exist based on so. One of my colleagues, Jordan, has finished off a patch series that I started in terms of implementing this idea of turn them into just random offsets and look them up in a different array, which that very quickly gets us to this interesting case where I was sort of starting to think about memory descriptors, where it's like, well, now instead of, sorry,
I was
Jason.
just going to reinforce, like Lorenzo's gone and converted all the swap entry code to soft leaves. And I think in that audit, it basically proves that there are no users doing PFN to page at all. It doesn't exist. So we don't need to worry about this, right? Like, I don't think you need to convince anyone that this is the right approach. This is the right approach. I think we all agree to that.
Cool. We'll continue with that approach. Sorry, everyone.
The one that I never quite, I know you need it, but the reverse, like page to PFN, like I'm not sure why you needed that, but I'm sure you do.
I don't think we ever really did. So I agree. And I think this patch series that's been posted kind of proves that. So there's one more question.
Yeah, quick question. Isn't that also what PFN map is for?
So PFN map is usually for actual physical address that really does exist on the CPU. You can sort of access that physical memory directly. Sort of the memory we're talking about here is remote on a device that the CPU cannot directly address.
I see.
It's a swap entry. It's non-present. It's a non-present PTE, which is the thing that we call a swap entry. And now we're going to call it a soft leaf entry, which means that the 8 bytes in the page table store metadata for the kernel consumption only. It's not accessible by the CPU. It's not a valid PTE. It's a little unintuitive if you haven't touched it before.
Yeah. So yeah, if there's no more questions, I'll go on. But that basically got me thinking in the sense that well, we're dynamically allocating these folios or struct pages now. That sounds kind of similar to what Willie wants to do eventually with memory descriptors. So I guess I just want to have a bit of a discussion around well, how does what we're doing fit in here? Can we sort of preload some of that risk in terms of having dynamically allocated folios? But also it got me thinking, do we even need struct pages or folios to map these things? I think I presented at LSFMM on the idea of using file-backed device private pages, and that very much, I think I've gone away and looked at that and decided that's not a direction that anyone wants to go in. So that leaves, well, what else do we actually use the struct page for? Well, it's page flags, it's migration and reference map, RMAP lookups. But if we're saying this is anonymous memory, why do you need sort of the mapping and index fields? You need them kind of for the reverse map, but then if we, a lot of that happens because you need to support multiple mappings of the same page, i.e. copy on write sort of forking behavior, which is not something that we terribly, it's a special case. It's actually a bit of a pain to deal with in GPU drivers, having this forked device memory off, because now you have to deal with contexts that a device driver has never heard about getting accesses to that page. So it's actually something we'd kind of like to go away almost, dealing with copy on write. So my thinking is sort of along the lines of well, if we just say this page can only ever be mapped once as an anonymous page, do we really need all of that extra data? Can we use something like a non-exclusive to say that, hey, this is just exclusively mapped and that's it? And then we, shrink our device struct down even further into this sort of all we really need is some flags to store the existing state that we've migrated to, and maybe the order of the page and the device offset. How much data do we actually need there? And admittedly, this is sort of still an exploratory idea. I haven't thought through all the implications, but it's kind of why I'm standing up here, to hear if anyone yells and screams too loudly.
Just you mentioned about page and exclusive, and page and exclusive will actually be stored in the struct page and not in the folio, because it's a per page information. So you wouldn't even need that on the struct device folio level that we dynamically allocate.
Yeah, okay.
But the other flags, I don't know, the dirty flag, do we even need that? I don't know.
I don't think we do, because it's just the only reason that you need a dirty flag is if it's swap backed somewhere. But usually when we migrate, we get rid of the swap backed entry anyway. This is if it actually has had
But
space.
is it really
allocated.
swap backed? It's like its own device special thing. So I don't even see like how we could be using that. So.
It's more a case of so today if you have one of these pages that's been swapped to disk previously, so it'll have a page allocated on the swap device. If that's then been made dirty, you migrate it to the zone device. You need to maintain the dirty bit because if it comes back, then it won't clean. It's a very strange special case, but I think we have to wrap up. So
And then you need a mapping information.
sorry, it's when it's still in the swap cache rather than the swap device. Yeah, there's some weirdness there. It's a really weird special case.
I think then you run into issues with the mapping and stuff like that, maybe. So
yeah. Yeah, that's I think what I think we do, and then we can don't have to worry about any of these weird little corner cases on dirty flags. And the only other aspect is we also have all these P2P DMA pages, which doubles up on the amount of storage space we need for struct page, which today, because we have to do both. But I'm seeing stops, so
yeah, you have to stop, unfortunately.
no. If anyone wants to continue the discussion, I'm around. So
cool, thanks.
I think he was a bit taller than me. Hello. Hi, everyone. My name is Pankaj. I work at Samsung as a part of the global open source team. Today, I'm going to talk about decoupling large folios from config transparent huge pages. I'm specifically talking about file-backed large folios, but we can get into discussion more, because in the RFC I posted, there were some things about anonymous as well, but my talk is going to focus on file-backed, but let's see where it goes. Okay, so a bit of history on why I started to work on this stuff. So I was working on a random feature, and which I had to disable THP to test. And in one of the kernel releases, when I was testing the feature, kernel panicked. I was like, what is going on? So what happened is I had a block device which had a logical block size greater than page size connected in my QEMU configuration. It was just there, and it just blew up. Once I started digging a bit deeper, I found that if the THP is disabled, then I cannot have logical block size of the device greater than the page size. I'll get to the reason why a bit later, but anyway, I immediately got a reply from Willie that, okay, it's a quick fix, but we need to really remove the dependency because it's a bit weird that in a block device layer, you have this memory management concept sort of tied in. Yeah, so but this got merged. But again, the bigger question was how can we remove the dependency where you have the config THP dependency from this case. Okay, and then the random feature I was working in also got merged. But while doing the review, Lorenzo also had a comment on this. He's like, it's a bit strange where any large folio stuff is predicated on THP, but not always. So again, there was more confusion on what THP really means, and there were more and more people complaining about this thing. Just to give a bit of context, how this all came into the picture. So when Matthew added the support for large folios, I think it was 2021, something like that. And so, yeah, the commit message, it also says that some features of large folio depends on THP infrastructure. So the dependency sort of got tied in. And once I started looking into it right now, one of the main features that it depends on is splitting. I don't know if there's any other feature that the large folios really depend on the THP apart from splitting. So right now there's a code in hugememory.c for splitting, and large folios sort of depend on that too. When you have a bigger folio, when you want to break it down into smaller pieces. It uses the splitting infrastructure to cut down to smaller pieces. It happens when you truncate or memory pressure and all the stuff, right? So what are the current issues right now is the config THP, like, it's starting to it's starting to spill over to block layer, as I already showed, and also file systems, like where there was a support for ext4 large block size support was added. Don't worry if you don't know what large block size support is, but essentially what the large block size do is, like, when you have a block size greater than page size, then you allocate large folios in your page cache. That's the main meaning. And again, this the same topic came up again, where Ted was really confused why, when you want to enable a file system feature, you had to enable transparent huge page support. Okay, so I already discussed a little bit with Matthew, David, and Z before starting this talk. So there were different solutions they proposed. So I want to really talk it through and get some ideas on how to go about this. Okay, so the first solution is sort of a more simpler solution, and I would call it like a small hack, but it gets the job done. It gets the job done, and the second solution is more of an elaborate one, and let's see what the community feels is the right way to go. Okay, a bit of context. In page cache, we have this concept called min order and maximum order. Min order means, like, whenever page cache tries to allocate some memory, it's going to allocate at least in min order chunks. What it means is, if I set the min order to be 2, then every time page cache allocates memory, it's going to always allocate 16K. I'm talking about x86, 16K chunks. But you also have another toggle for max, where, let's say, if there's an IO that's bigger than the min, then page cache will optimistically try to allocate bigger folio. And the one important concept that's sort of tied in, which is needed by the file system, is your folio cannot be split lower than the minimum order. So if you have a min order of 16K, you can never split a folio lower than 16K. But let's say there's memory pressure or truncation happening when you meet this maximum when you meet a folio that is bigger than minimum order, then you try to chunk it up into min order chunks. So the solution, what I was thinking based on the session, is the first solution is, what if we set the minimum order and maximum order to be the same? In that case, we never use the splitting infrastructure. So you sort of softly remove the dependency between your large folio, and then you don't use the THP infrastructure at all. It's really not that complicated. You just have to do some changes in the page cache, and so I was able to run. So I tested it on XFS, and I ran XFS test. It was fine. So yeah, Hannes, you have a question here?
Thank you. I really don't see why we would need to split folio which are in max folio order, because the max folio order there. To my understanding, we are setting the max folio order to the LBS size, right?
Min.
No, the min folio is right. Okay, so and the max folio is the max THP. Okay.
Yeah, in most cases, I think it's 2NB is the maximum.
Okay, yeah, no, then okay, it's right. I retract. You're fine.
Okay, yeah. Yeah, so I sent the RFC. I think there are already some comments, and yeah, will you have some? Oh, no question. So I thought he had a question. Okay, so yeah, so I already posted RFC for this. Let's see, and the other solution to this is, I think David already gave some idea. He's like, right now the issue is we sort of have the allocation and the mapping sort of intertwined, so what if we can sort of remove the dependency between the allocation and the mapping. So the point is, if THP is disabled, we can still allocate large folios that are like PMD size, but we don't map them with PMD mapping. We just do PTE mapping for non-THP cases. I think it's a bit more involved. It's above my pay grade, I think, at this point. So I started looking into it. It was like a bit much. So I was like, I started working on the stuff that was like, okay, let's just get this thing done and see how far it goes. And then I want to get some ideas, like if this is the path I should go in, then I can really start, because from experience, I've seen sometimes I do a lot of work and then I go to the community and they said, no, we don't want this. So it'll be a nice time to ask, like, if this is the real direction we want to go, or because the one of the big questions is who disables THP? Like, are there like use cases where they disable THP and they still want large folios? I think that are the main question that needs to be answered.
I assume it's mostly about like kernels that want to like have a very small footprint, I would assume, right?
Yeah.
That like you say, well, like I don't want THP code. It's too much. It's not required.
I'll leave out, and partly some architectures just don't. They never added the support for THP.
For PMD mappings,
Yeah,
right?
I mean, let's talk about Alpha, for example. Right, Alpha does in hardware have support for it, but nobody ever did the work to make Alpha support that in Linux.
Mm.
Why is that a config? Shouldn't the MM just sort of know what its underlying architecture supports in terms of leaf entries and just get rid of the PMD leaf isn't supported, so I just get rid of all the code related to it? Like, I don't see why it needs to be a K-config.
Tradition, I guess.
Yeah, exactly. But I mean, that was going to be my like option 3 is let's just get rid of. Yeah.
I think there is one more case where you certainly don't want THPs. It's real-time systems,
okay.
because you don't want like the splitting and all of the stuff. And also like some, again, like from the size perspective, some people just don't want like KUHPHD code, for example, in the kernel compiled.
Yeah.
But maybe there is a way forward that you can just say that like THP will always be around, and whether you actually compile in all of the mapping stuff, like the PMD mapping is then actually guarded by I think there's like an Arch config Arch supports transparent huge page, and then some weird Arch supports transparent huge page POD, which is even more disgusting and probably. I mean, there was some work on from Luis Capitolino, like he sent out that we actually like have an indication from the architecture if like support for PMDs is enabled, should have the same for PODs. And then it's really just a matter of allocating and splitting them. And on the other side, it's how we map them. And if an architecture does not support PMDs or PODs, there is no reason to compile the code in. For KUHPHD, maybe you could have that as a separate config option to say, well, maybe if I don't want that, then don't have it.
So what I'm hearing is like we sort of, the long-term goal is to get rid of config THP as an option, and so we do whatever we want, and if the Arch supports THP, like the PMD mapping stuff, then we use the
Right, and I think there's like there is like a compile time thing to it. Like if an architecture just doesn't support PMDs, then there's no need to compile it in. And then there's a runtime option where, for example, on x86 32-bit only supports like PMD mappings with some magical CPU features. I don't remember which ones, but I think PowerPC has something similar. Once you move to PODs, it's probably the same thing. So there's like a compile time and a runtime thing, but that just defines how you map it. We could still allocate a 2 megabyte folio even without PMD mappings and map it through page tables. Just that
it's not.
It could be done, right? Yeah. But for example, KUHPHD with like the PMD code doesn't make any sense anymore. But we could have that.
Okay.
Oh, there is a question from Lorenzo through Luster for some reason. It's very, very hard to actually truly disable THP, except not to set config THP once automatically. Yeah. Yeah, not everybody wants automatic large folios is probably like a good argument. Lorenzo has no only YouTube access. So he's probably not paying. But yeah, I think like one step forward with that in mind would be we have to figure out which use cases actually disable THPs.
Yeah.
And I mean, I know about real time because there you just don't want any like splitting,
Yeah,
unmapping,
THP.
overhead of
Yeah.
that. But
Yeah.
maybe there are other ways where you just don't want them. Maybe because some of the features are still shaky, like Nico, for example, is working on MTHP support for KUHPHD. And until we have that, for example, it's not as reliable to work with that.
But anyway, yeah, thanks. I'll talk about this a bit more after the talk. Yeah, thank you. And
Hi, everyone. I'm Liam. Work with Oracle. I'm here to talk about the life cycle of the struct. So I guess to start off, I hope everyone knows what the struct is. It's a struct in the yeah, if you don't, you're probably in the wrong room. So recently there's been a lot of problems, or a few problems, with the way that the struct is sometimes in an unknown state. And it's caused a number of bugs, and I'm just trying to figure out a way to better handle having a structure that can be found in multiple ways. And sometimes it's not in the right configuration for the ways that it's been found. So we've had issues where there's a task with no VMAs. They're pretty short-lived. It's usually a race condition, but they're still found, usually by Sysbot. There's also a potential that the setup doesn't completely succeed. And so we're in a state where we have the struct semi-configured, unknown where we failed, and then we drop the lock before it gets to the exit path. The exit path's kind of complicated. So the teardown has kind of a juggling of a read lock, and then there's also a MMU notify or MMU flush, which spans across the read lock and the right, the read lock drop and the right acquire. So it's kind of a mess. It got that way, but there's a reason it's that way, but and it's for speed, so you don't really want to mess with it for corner cases. And then there's the kind of aspect to it as well, where the teardown of the PTEs are happening, and you could still find the struct and actually try and use it. And I skipped 2 slides. So right now, what we've been doing is kind of working around each problem as they come up. So one of them was a uprobe issue where we ended up moving the uprobe lock, but using the locks are slower, and we're trying to kind of get away from using locks for longer. It's great when you can detect the problem area and it's only in the error recovery path. That's kind of the way that it happened in the teardown of the VMAs. But for the uprobe stuff, there wasn't really a way to do that. So the other thing that we have in play here is also that we have these flags, and those are mostly used for the or historically used for to say that the is unstable. Or to skip it. So we started getting into like these situations where we have that either don't have any memory left and we're asking it to free it, or we're racing to free it, or there's all these really kind of odd situations, and we don't want to just go back to
one lock to rule them all. So I was kind of trying to come up with some strategies where we could not have a heavy-handed implementation on detecting when things have gone wrong, and still maybe be able to find the MM. The other thing that complicates this is the way that we find MMs. There's like a number of ways because it gets put into multiple trees and they're cross-linked with other tasks. So we get into situations where you're looking at a VMA from one tree and it leads you to another tree, or sorry, another MM struct. And then in that MM struct, it may have been halfway through teardown. So we want to try and find a way that, like I said, we could unify these things as opposed to continuously come up with or find or discover when Sysbot emails us en masse about a new bug. So I was looking for anyone who had any ideas on that sort of front or any strategies that could fit.
Hey, Liam, you haven't mentioned MM grab and MM get yet.
Yeah, and So what about them?
I was about to say that my understanding, which may not be complete, is that one of them gives you a handle on the memory, and if you have that one, then the memory is there, but you don't know what's inside the memory, and you don't know that the task hasn't been destroyed. So like all your cross-linking and stuff should be using that ref count. The other one, I think it's grab, says that the task is still alive and the VMAs are still active. So when I'm reading your problem statement, I'm getting the feeling that stuff is not using the grab ref count correctly, or or something like that.
Yeah.
I think the problem is like when you create like a new, like when, for example, when you fork and you create a new MM, then I think you initialize it such that somebody else could come around and actually do a grab or a get. I don't know, like use
Yeah,
the
I get
memories.
confused about the two as well. There
That would probably, maybe that should be reworked at that point, that you say, well, like you can only like get a hold on this once I'm done with initializing it.
Maybe your error path may just be in the wrong place, right? Like the teardown of the VMAs should probably be done when the grab reaches 0 kind of thing. And I seem to remember, gosh, I don't remember, but I seem to remember there was some code in like exit MM that waits for the grab to go to 0 or something like that.
No, I think that the exit path, well, okay, so which exit? Mmap exit or?
I don't remember.
So the mmap exit, when you get in there, there's already no references left. And you can actually get to the MM without a reference still on it.
That's broken.
Yeah.
But again, are you sure we're talking about the right because there's two references. There's the reference on the memory and the reference on the VMAs. And yes, you can get to you can hold the reference on the memory and then try to reach the VMAs, but you should fail your grab at that point. And if you're not working it that way and you have a pointer and you don't have any reference, you're screwed up. You're hopelessly broken.
Yeah, I get confused about the grab and the get frequently. There's also like a grab not 0 or something.
Well, the grab not 0 is for the case we're just talking about, where I've got a get and I've stashed the pointer away someplace, and then sometime later I come back to that pointer and I want to get back to a live locked or ref counted MM struct. Then I do MM get not 0, and if it's exited in the meantime, then that will fail, and that tells me that I've got a zombie MM struct and I just don't do anything with it. Like that's how this is meant to be used. And then there is some sort of wait that waits for the ungrabs to happen before it destroys the stuff that the grab is supposed to be keeping ref counted, which was never entirely clear to me what that encompassed. But I think it's the VMAs.
I don't think so. No. So some of the races that we see, and maybe you can explain how we can get into this situation. You can actually on map
everything. And before that returns to user space and gets a sig seg v, something else can get the MM. So you actually can get an MM with 0, and this is a problem in the scheduler. So I would be very surprised if we're ref counting incorrectly in the scheduler.
I just remember enough about that 2 ref count scheme is that one is subsumes the other. So there's an overall ref count, and then well, you've got an overall ref count for the MM struct that prevents you from freeing it, and then one ref count is handed out to the separate ref count thing, and that one's how many user space things are using it. So that counts up and it counts down. When it gets to 0, then it decrements the overall ref count by 1. So it's just one user of that. And so yes, you can definitely get an MM struct with all the users having gone away, but there may still be ref counts on it from the overall don't free me yet ref count.
But what does it mean when the users are 0? And why are we talking about no VMAs? Is there something else
Well,
going
the
on here?
word VMAs doesn't come up in that. It was
well, that's why I was saying I don't know what the ref count actually protects.
Yeah, and you can get it without a ref count.
But why does the scheduler care how many VMAs are in an MM struct?
Because what it does is it looks, well, this particular portion of the scheduler gets the VMA and then checks to see if it has a VMA, and if it doesn't, it resets, and then it runs a loop across all VMAs. Yeah. What's that?
Why does the scheduler look at VMAs?
Say again?
Is this in tree or
Yeah.
some other?
Yeah, I broke it, and that's why I know it exists. And I know this happens because why I broke it was like, why is this like this? And so while I was going through for my conversion to the Maple tree, I changed the loop as opposed to, instead of being a 4 nothing VMA next, I changed it to a for each VMA, and it broke. And this was the fix, and this is why the fix exists, because you can actually get to that state where there's an MM struct with 0 VMAs. And then there's other ways of getting there, right? We think that because we have this, we have another lock, then obviously this is fine. So we have like copy on write, and we look at the next VMA, and then we go to that VMA's MM. So we're going through the VMA linking through another tree. So you have, a series of trees. It happens, I think, also in the file back one where you have VMAs that share a file, and you go through the IMAP, and then you say, oh, well, who else might have this? And the RMAP. And then, and you go back and you go through that way. And obviously nobody's going to be freeing this because, and the MM struct is fine, because if you look at that rmap.c, the nice list, this lock is the ordering, it means that this is safe, but it actually turns out it isn't. So this is.
I think that what you're saying is you can actually obtain maybe not an MM reference. You can look at an MM by walking the RMAP, right? Because we set up the RMAP as we, for example, clone a process as we fork, because we have to keep page migration working while we fork. And I think that's where it all gets nasty.
Yeah, and then you get to a point where you go into that MM struct and you say, oh, well, can I merge with previous and next for some reason? And maybe there is no previous or next. Maybe you put in a special pointer in there because the clone failed, and then everything blows up because that's what happened. So
I think the thing you talked about, the scheduler, could it be that it's like related to NUMA hinting, something like that? I know that like scheduler, when you reschedule the different schedule, it tries to move memory, and probably that's like why it looks at VMAs in the first place.
Yeah, so it's like this kind of it's a tangled web, and because we don't really have the MM struct lifecycle well defined, we get into these situations where people look at the locks, and rightly so, it looks very much like there's not going to be a problem. And then some back entrance way, you get into these problems
where you're walking a structure that's not actually fully initialized.
It's because people are being lazy with the ref counts, right? Like if you're putting a 0 ref count thing in a lock protected structure, you still have to get the ref count when you take it out before you use it, and you have to do a ref count inc if not 0 kind of test. And that avoids all these stupid races where I've started to destroy it, but I haven't yet reached the point where I grab the locks and take it out of the structure, but you still can't get in the back door. Like, and I think that's what's gone wrong here is these ref counts are not being used consistently and correctly.
So you think it's a ref count, completely ref count issue?
In my experience with these classes of bugs and other areas, that is the answer usually.
Okay, so the other problem is like right now, like I said, we have okay. Just got to stop. All right. Well,
thank you, Lee.
Thanks. I was worried I wasn't going to have enough to fill the time. Thanks.
All right. I think this is going to be the last talk for today. But best for last, Harry, right? Oh, yeah, great.
Hello, everybody. I'm Harry. I work on memory management at Oracle. And today I'll be discussing the reparenting method. I mean, simple and smart reparenting method to eliminate zombie memory C groups. Okay. So memory C groups become zombie when they are removed from the hierarchy, but their resources live longer than their memory C groups themselves. So they become zombie. This is because LRU pages take a reference to the memory C group to make sure memory C groups don't go away. But if you create and destroy memory C groups frequently enough, they can accumulate and it could waste a lot of memory. And actually, we've been observed like hundreds of gigabytes wasted for memory C group and persecute data just for zombie C groups. So it's a real problem. And I think other folks are also experiencing this problem. And actually, kernel pages and slab objects don't contribute to the zombie problem anymore, thanks to Roman's work, because they don't pin memory C group, and they are charged via object C group API, and object C groups are reparented from child to parent when they get removed from the hierarchy. So why don't we do the same thing for LRU pages so that we could reclaim memory C groups? And actually, there's a work from Qui and Muchon at ByteDance to work on this. And yeah, so the question I want to raise today is that the implementation of reparenting can be either simple or smart or quote unquote complicated. The simple method works and it's simple, but it could maybe cause suboptimal performance because they don't respect, it doesn't respect how hard pages are, and it just it just repent memory without considering hardness. And yeah, and on the other hand, maybe we can do better than that and make things more complicated. But are there any real workloads that might fail under simple method so that the complexity of the complicated method will be justified? So that's the main question. And I'm going to argue that without data to back up, it is better to go with simple approach first and then make things complicated later. So yeah, that's the question I want to raise. And so simple reparenting method simply splice the whole list from the child LR, the LR list of child memory C group to parent memory C group under LR lock. So it reparent all the pages at once with the lock. And after reparenting, the child memory C group can be released. But as you can see on the diagram, suddenly pages from the parent are considered the colder within the LR list, regardless of their actual hardness. So basically, it's adding some noise to RLU mechanism, and MM could reclaim wrong pages if we add enough noise. So with traditional RLU, we simply splice the child inactive RLU to parent inactive RLU and child active RLU to parent active RLU. That's pretty simple. And we do that under the RLU lock of child and parent. And yeah, that's it. It's pretty simple. And with multi-generational RLU, it can be a little bit tricky because maybe some generations may not even exist in parent, as in the example. So the trick is to artificially max out generations in the parent and splice those pages from the child to parent to its matching generations, like this. So yes. So theoretically, if someone creates a C group and spawn processes and they touch a huge amount of file memory in a short period of time and then kill them and remove the C group, then it's reparenting a huge amount of memory to the parent RLU. And if someone, theoretically, if someone does that, you can full RLU mechanism to reclaim wrong pages. But yeah, again, does that sound realistic enough to consider more complicated ones? And yes,
my question would be like, in which scenarios where we offline these C groups would we actually, like, in which scenarios would we actually consider that a problem? Like, are you aware of any scenarios where you just like offline a C group and then you run this like crazy reclaim workload, or is this more like something that might not be as urgent?
What's the damage if it happens? I mean, we just fault it back in later. I mean, yeah, but waste cycles in a race condition in an unlikely scenario.
If you're offlining the MemCG anyway, it's probably likely that the memory is not needed. Not absolutely true, but it's probably likely that it's not needed, and or at least cold. And in fact, MGLRU prefers to reclaim memory from recently offlined MCGs for that reason.
But I think we don't know if it's cold or not, because it can be 5 pages that is accessed by different memory C groups, and we don't really know, I think.
Just one thing, we do have this problem at Meta for several years. Like the child C group dies and we start the job, but we reuse the page cache and the parent C group is accounting for it. So we have this problem, but we don't have a solution.
In the simple approach, would you adjust, like, I think you said you splice the list, and I assume like you treat the offline memory as cold one, right? Like you would move it like to the end of the list or to the front of the list, or how exactly would you do it?
It adds to the end of the list, but it's not because we assume it's cold. I mean, it doesn't matter if, I mean, it just don't care because it focuses on correctness rather than performance. So, and yeah, that's the question for today, I guess.
I think the common kind of scenario is like you have systemd and it just runs every workload in a separate C group. And then if you restart this, basically the same workload, I don't know, using a new binary or like new arguments, you get like a new instance and like you need, you have this problem. But honestly, I'm a little bit skeptical on LRU, like LRU reparenting in general, because like if you have a new instance, right, like you reparent all the page cache, but now suddenly like a new C group is using the old page cache, and you like all your kind of MemCG functionality, like memory protection, memory statistics is not correct anymore. So I think the real solution is in user space, and it just like you don't need to create memory C groups all the way to live C groups. You kind of terminate memory C groups at a higher level. So like a new instance will belong to the same memory C groups. And like I don't see any other solution.
So essentially what you're saying is by doing the regrouping and then restarting the workload and getting a new C group, essentially the new C group would not have any like pages because they're all in the wrong C group now.
Right. Yeah. And kind of moving like pages from old C group to the parent C group doesn't solve any kind of real problems with statistics. Yeah, it helps to kind of release the old C group internals, but yeah, it's kind of a smaller problem from my perspective.
Yes.
We have a C group, and you can have multiple children C groups that are running different tasks of the same type of work. The tasks are similar, but they're stacked, and then you have this problem, right? Yeah, there's no perfect solution.
Oh, yeah.
But the statistics on shared pages in the MemCG have always been sort of non-working. So I don't feel like it's making the problem any worse.
So yeah, we don't have a good solution to, the statistics being inaccurate when pages are shared with memory C groups. But yeah, I think that's bigger problem than resolving zombie memory C groups. So yeah.
So I'll take the opposite approach to this. Let's assume we go with a complex or smart mechanism. Is there a way to do that that just doesn't turn into a heuristic that fails in a different way?
Oh, that's great point. And yeah, you're right that it's just or heuristic logics hoping that it will work. It will somehow work better than simple one. So
Because I can imagine, for example, like the LRU inversion problem will eventually work itself out, right?
Yes.
And so that's the simplest case, and you just deal with it. You could maybe zipper logic it, and then you get some semblance of randomness that it's better than the trivial case. But how long are you holding the LRU lock for? And is that beneficial? You could try that, but that's another heuristic that will just fail in a random case. It solves itself eventually. So it seems better to go with simple and then let people test some.
Yeah, that's what I hope. Hopefully no one complains after, simple method goes.
He says splice from the other end. Maybe the child's page is colder, not the parents.
Oh, I think.
Yeah, that's another here.
I mean, I guess if we would have some example workload, you could play with some policies. I don't know, like randomly splice stuff. Maybe, maybe that.
Yeah, I think we could splice
well
to the both end, but
yeah. So on Vlasimel's note, I think we had a patch set recently trying to change the LRU to stop updating on exit, and that was a really bad plan. I think Johannes tested it, and it turned out that you do want to update the LRU on exit. And if you're assuming that when you're killing a C group, you're exiting, then, which I think is probably right, you should update the LRU. And so the child's stuff should go ahead of the parents just on that logic alone.
I'm not sure
I think the problem is if you only have a list and like in the list is hot and cold stuff, you don't know like in comparison to the parents list, like how are they ordered, right? You lose all of the ordering. I think that's the biggest problem.
Yeah, but when a task exits, we already update the LRU to that. Everything in that child is updated to current, is it not?
I think like you mean all of the processes exited and you...
Yeah, the process exits, we update the LRU list so that you can restart the task faster.
Exactly, yeah.
Right.
Yeah.
So if the child is exiting, then it should be updated. So it should go
I think
ahead of
the
parent.
issue is really that you have two lists with an ordering, but you don't know how they compare if you merge them. And I think the answer would be don't merge them in the first place and try to reuse your memcgs if you're restarting a workload.
Yeah.
I think that's the only logical conclusion, really. But that's a user space problem.
But you cannot tell people what to do, So, I think the time.
Any last question? Yeah.
You said you had multiple gigabytes of wasted memory for how big? I mean, so they're 2K. MCG is 2K. How? I mean, how do you have like?
Oh. Yeah. Oh, yeah. If you run wrong enough. Yeah.
Basically, your failure mode is you've got shared pages in the page cache, and like every single page cache page is referring to a different C group that happened to be the one that was active, that happened to fault it in. And if that's your failure scenario, what the heck is the LRU doing in that case? Like, it seems like nonsense. Right? Like, having the LRU for shared pages be per C group doesn't strike me as something that makes a lot of sense.
Memory is not really designed to work well with shared resources. So
yeah, we keep coming back to that MemCGs are just broken when you put shared things into that.
Yeah.
So I don't know that your solution is making it any worse, right?
Okay, I think.
All right, so we came to the conclusion that it doesn't make any sense. That's a nice summary for the micro conference. Memory management sometimes doesn't make any sense. I want to thank you for giving this talk, of course, and of course everybody else who participated either as a speaker here or you from the audience. So thank you so much for attending, and I guess we'll meet some of you at LSFMM or at LPC next year then in the memory management track. Thank you. Oh, we're going to be, of course, yeah. Like, see you at the evening event, of course, for a beverage of your liking.
Trisha said we can leave them there, so
we're very close to them.
I don't believe this. But we still need to. I still need to kick everyone out. Apparently, we kicked everyone out.
At least you can send it out to customers.
Let me see. How many rooms are still running? I'm running out of internet. Maybe they shut everything down. I don't know. No, it's still. I do have internet. And this one does work. So, you're just taking a bit too much to dig status from baby. Yeah, here. Whole